In last week's video, I talked about, the basics of logging, how to set it up, how to, do basic formatting. If you haven't watched that video and you don't know how logging works, then make sure to go and watch that. In this video, I'm going to presume that you're already quite experienced with the logging module and just want to make it a little bit nicer. I'm making this video because a lot of tutorials and a lot of Stack Overflow answers on the interwebs, as I'm sure the youth call it nowadays, are all very complicated. They all add extra unnecessary steps. They're all along the right lines in terms of what to do. They all work, but they just all make it so obtuse and overcomplicated, and, well, not obtuse, verbose, I suppose is the word I mean. But in this video, I just want to show off a simple way to get it working across not just, a file, but across, the whole programs. This will work, across any imported files and everything. So we're going to start by importing our logging, and then we're going to have a constant. I don't know why it's done that there. We're going to have a constant. You can really call this whatever, it doesn't necessarily matter. But this is going to hold our formatting information. Now we are actually going to be using f-string formatting, and I will show you how to do that as well, because you don't have to use the old style formatting with the logging library. But, we're going to do just as a as an example, we're going to have in brackets, we're going to have level name, and we're going to have that centered. Now you can't actually do this with percentage syntax, which is why I actually have, the f-string quote, or the format string, I suppose it's called, syntax. And then we're going to have the name, and then we're going to have the message. So quite a simple, format. And then we're going to have a mapping of formats, and this is going to have all our different logging levels. So we're going to have logging.debug, and then we're just going to leave this as an empty string for now. And then we're going to have one for each other level. So we're going to have info, we're going to have warning, if I could type in the right case, that'd be nice. We're going to have error, and then we're going to have critical. And each one of these is going to have a different style of formatting. Now I'm just going to leave the info standards, unchanged. But for the rest of them, we're going to use something called ANSI color codes to do this. Now, if you're not familiar with ANSI color codes, then I recommend looking them up. But we're just going to be utilizing these, to provide color to our terminal output, because you don't need any libraries like color logging, and I think term color is a different one that does colored text in the terminal. You don't need any of that. There isn't any insane magic that they do. They just use ANSI color codes. So we're going to be using those to do this. So for the purposes of this video, I'm going to stick, quite simple, and use the 8 color system. However, there are 16, I think, and 256 color variants. Yeah, 16 and 256 color variants that are a little bit more complicated, but I'm just going to keep it quite simple for the purposes of this. I've also realized that the 8 color system doesn't actually have a gray, which is kind of annoying, but we'll work with it. So debug, we're going to make cyan, because why not? So every ANSI color code starts with \33 and an open square bracket. You can also use /u001b and an open, but I don't see the point in that. And then for our cyan color, it's 36M. So they all end in M, and then this number denotes the color. So for example, if we want cyan, it'd be 36. And then we have a format string. And then we pass just our format in there. And then at the end, we always need /33 open square bracket 0M. And this is our reset character. So this, resets all string formatting back to its defaults. Info, we're just going to leave as a default, as I said. And then we actually do need F strings for all of these. And then for our warning, we're going to make this yellow, which is 33M. And then we're going to pass our format in there, and then we're going to have our same 0M reset character. And then for errors, we're going to have orange, if that's possible. I don't think that is possible. It's not possible. Okay, we're going to have red, which is 31. And then we need to reset that. And then for critical, we'll also have red, but we'll also make it bold. So what we can do is we can do /33 and then 1M to make it bold, and then another separate code to make it red, so 31M. Then we have the format, and then /33, 0M to reset it. And you know what, we'll actually swap the debug and the info around. So the debug is just, you know, normal boring text, and the info actually has some something nice about it. So after that, if I just switch back to my notes, we create a custom formatter class. We create a class called custom formatter, and then that inherits from logging.formatter. So this will be our formatter class. And then we override the format method, take self and record. So each logging entry has a log record, which contains, you know, various attributes, which is how this string actually gets formatted. So anything inside that log record can be here. So you have, you know, log record level name, etc., etc. And we're going to be using some of those to actually help out here. So we could do log format equals formats, and then record dot level number. So this is the actual number of the logger. So, you know, an info message will have 20, warning message will have 30, etc. And this is how we access the actual formatting message to use. And we do formatter, that is not what I want. VS Code, thank you. Equals logging.formatter log underscore format. And then this is where we set our style. So style, if we pass an opening curly brace or opening curly bracket into this, we set the formatting style to f-string formatting, or I suppose format strings, rather than the percentage style. I'm not sure what the name is, but yeah, you can do that like that. And then we do return formatter dot format. I don't know why I didn't put the dot in there. I definitely typed it. Record. And then from here, we just need to actually create the logging object. We need to set the logger up to use this formatter. So we have to set a handler. So this is logging.streamHandler. So this is a handler that just, you know, sends the logging messages to the terminal. We do handler.setFormatter custom formatter, and then we actually have to pass the instance, not the class. And then from there, we just create our basic config. Set level equals, we'll just set this as logging.debug so I can show all this off. And then handlers equals a list, or I think you can take a tuple or a set as well, I'm not sure. But we pass our list of handlers in there, which in our case is just handler. And then that's it. That is literally all we need to do. So we can now do, you know, log equals logging.get logger carded logger. And then we can do log.debug. This is a message. I'm just going to copy paste the same message in all of them, just in the interest of time. And then we're going to create one of every default. While I'm thinking about it, actually, you can actually custom format custom logging levels as well. So if I just bring over my notes, this is from a library that I've been building, but I created, you know, a custom logger to help with it. If you wanted to type hints as well, here you go. But as you can see, I created, you know, a custom level called trace, and then I set a format for that as well. So you can, you know, if you have custom levels, you can just put them in the dictionary and it'll work just fine. But if I just finish off this real quick, and then if we run, that's still from the old video, hello logging, it will break. What have I done wrong? There is no underscore between level and number. There we go. So you can see, oh, I've actually set this slightly wrong. This is supposed to be, I think 9 looks, I think an odd number looks better on the whole. I know critical looks wrong, but warning and error and debug all look better than if it was 8. If I set this to 8 real quick, you can kind of see that while critical looks right, debug and warning and actually error both look wrong. So So I tend to have it as 9, and then because you don't see critical errors all that often, then it's not really a problem. But as you can see, our debug message is white, our info message is cyan, our warning message is yellow, our error message is red, and our critical message is bold, and then also red. So that makes it a lot easier, you know, when you're looking at logging messages to like see exactly what's going on. So you can see, oh, this is bolded in red, that must be a critical error. Your eyes are drawn to it more if it's just a block of white text. So colored logging, or just pretty logging in general, is really useful and really helpful. A lot of libraries, well, I was going to say a lot of libraries use it. That's not really true, actually. There's not many libraries that do this themselves, but it is, in my opinion, something that should be used more, and it's something that is really easy to do. Like, you don't even need the color logger library, because you could just do this and you have so much more control, and it's not even that difficult to do. A lot of tutorials and Stack Overflow answers would have you believing otherwise. So it's a lot harder than it really needs to be. But there you go. This is why I wanted to make this video. So that is everything I wanted to talk about in this video. Creating applications with synchronous and asynchronous implementations can be quite awkward at times. You have to think about, you know, whether to have things in a different class or whether to have things in different variable names or function names. And if you have stuff in function names, you know, how do you make it distinct? Do you just put async in front of it, or do you make it different in these different ways? And it can be really awkward for the user as well to, differentiate between these two, especially have some slightly awkward names. And what I'm going to show off in this video is a way to make that no longer a problem. So like the thumbnail said, we will learn how to do something like that. So my function being the same function, being awaitable and non-awaitable at the same time. So what we can use is a library to do this. So we can do pip install xsync. This is a very new library. It was only released a few days ago. And I know this because, once again, it's one of my libraries. Like the analytics video, this is a bit of an advertisement. But this was a collaborative project between me and my friend John. He kind of came up with the original idea and the original proof of concept, and I turned it into a decorator and ultimately created the package xsync, as you see here. And xsync provides a series of decorators to make, what I just showed off actually possible. So if we just import it, and we're going to do, reading a text file as an example. So I created our top secret text file off camera. We'll have to wait to see what's in there. But to actually create our function that can be awaited and not awaited, we have to define something called a hybrid callable. Now this is what xsync refers to it internally as. And to do that, we can use xsync.asHybrid. And you have to have these brackets, otherwise it doesn't work. And then you just have, say, read text, and then the path. And we can do with open, path, just kind of as you would normally do, as f, return f.read. And this, reads our text file and displays it, and returns the value of it back out. It's pretty simple. We're going to actually have a strip as well to strip the new line away. And we also need an async implementation because this isn't synchronous. So what we can do is we can create, async read text here with path. And then if I just install AIO files real quick, which is a pretty good library for asynchronously reading files, and just import that up here. And then with AIO files dot open path as f, we can then return await f.read .strip, and I think I need to do that. Yes, I do. Oh, that's not liking that. Why is that not liking that? Because I didn't make this async. That would probably help if I did actually make it async. So this is the async implementation of our function up here, but it's not currently, actually workable. So what we can do is we can do xsync.set async implementation and then pass read text in there. So what this decorator is doing is it's taking this function, which has been registered as a hybrid function, and we are setting the async implementation of our read text function to this. So we do actually define a separate function, which can still be called on its own. But now, this is essentially telling Xsync that when you await read text, you should actually run this function instead. So if I just, put up a bit of an interface like this, if name double equals main, spelt correctly, that would help. So we could do, read text and then top secret.txt. And then we can have our main here. And then we can await async read text, top secret.txt. I just want to prove that both of these things work on their own. And then it would be async io.run main. And if we now run our video.py, we can see that I've missed out another async. Wow, I am really bad at this. We can see now that we didn't print anything out either. I am a phenomenal programmer and forgot to actually make it print the statements. But we can see that the world is in fact, as we all know, a dinosaur. It's not flat and it's not round. I am officially part of the Dinosaur Earth Society. And for those that don't understand sarcasm, that was a joke. But I just thought it was funny, alright? Shut up. So we can see that they both work fine. But instead of async read text, if we just do read text like that, it still works. And that is because if I just have a print statement here, just to show that it is definitely working. Print sync async. So you print sync and then the contents of the file, and then async and the contents of the file as well. Because, as I previously explained, this async read text is being set as the async implementation of read text. So when read text is run, or when it's awaited, Xsync sees that and goes, oh, I need to run this instead. So it's basically just running this function. It's kind of cheaping out a bit. It doesn't create its own one, but it's better off that way because you wouldn't just want to run this, synchronously in a coroutine, because then it's defeating the point. You want to have your async implementation, but you want to be able to run it like this. This is the best, possible solution that you could have. As well as functions, it also works in methods as well. So if I just, create a class called reader real quick, and put that in there, remove this line as we no longer need it, and then have our self and our self. And if we do r equals reader like that, oh my god, I cannot type. I can never type on videos. It's just a thing. I've just kind of accepted that I can't type on videos. But if you do that, we can see that it does exactly the same thing. Doesn't matter if it's a function or a method, it will just work. It also works on class methods and on static methods as well, but I'm not going to bore you with that. You could experiment with that in your own time. But yeah, that is how to make functions and methods, both synchronous and asynchronous. So this is just really nice, fluid, dynamic interface. To allow users to just use it a bit easier, and it's really neat as well. But yeah, if you like the video, then consider liking to let me know. There is something you may have seen around before called if name equals main or double equals main, and you may have wondered what the hell that even means. Well, this video is going to show you, because it is an incredibly useful thing to know, and really should be in every Python script that you write. For those of you that have done other languages before, especially, at the very least C language, I'm not sure how well this translates to every other language out there, but it works sort of like the int main in C++, or just any main function in like other C languages, I think most other languages. It serves as an entry point. And its main goal in Python, because you can sort of have an entry point everywhere, is to make sure that it only runs precisely when you want it to. And I'm going to show you sort of what I mean by that. So we're going to have our file called test.py, and then we're going to have another file called program.py. Program.py isn't going to have much in it, but test.py is going to have a decent amount. So this is going to just have import test. That's literally all it's going to have. It's not going to have anything else at all, unless I decide to put something more in test. I haven't really decided how I'm going to do this yet. So let's say we have a function called hello, and then we have the name, and then we return, hello name for just a really basic example. And then we have string equals hello name. I probably could have done a slightly easier example on this, but whatever. Ethan, and then just print string, for example. And then we do a py and then a test.py, and we can see that it prints hello Ethan. And now if we print py program.py, it also prints hello Ethan. Now this shouldn't normally happen. There are instances where you would want variables in imported files to be loaded. So for example, if you had a logger or you had constants that are important in the file, you would want it to be defined there. So say this function, for example, you would want this to be defined. See, I knew there was a reason I did it as a function. You would want this to be defined for later use in the file. So say if you had a class that called this, then it's there and available even when it's imported. Mainly, helpful in packages. For example, we need stuff around the place. But this sort of thing you wouldn't normally want. This is, it looks quite debuggy. Really, we wouldn't necessarily want that to be run or shown when we import test into program, because we might want, test.hello Nathan, for example. That's the next name I can think of. And now if we do that, we need to print it because it doesn't. It returns it, doesn't it? We have hello Ethan, hello Nathan. So what if we only wanted Nathan in there? We can use this if name double equals main to do it. So if name equals main, it will now run this code. So if I do py test.py, we do hello Ethan, as you can see above, py program.py now just outputs hello Nathan. You may be wondering what in the ever-living is going on here. So I'm going to quickly explain all the parts of this so you know exactly what's happening. So name is a dunder string. So dunder means double underscored. You may hear sunder as well, which is single underscore. But double underscored attributes, variables, functions, methods, all these things, often defined as magic methods or magic whatever, and they are predefined by the library or predefined by the language. Things that just exist at runtime. You don't need to define them. These are just things that Python does for you. It just goes, hey, this is what this is now. And this double underscore name is the name of the module per se. So if we were to print name here, see the name is main. Now this is because this is the file that we are running. However, if I were to print it, if I were to import it from program and I were to print it here, for example, it would be test. Because test is the name of the file, or at least that's what it's been imported as. I do wonder, if we were to do that, would it print T? It would not. Okay, that's fine. I didn't know. Felt like testing it. So test is the name of the module that we're importing, therefore name is test. However, when we import it, when we don't import it, when we just run it, it's called main. And this is it's intentionally bizarre to try and reduce the chance of a conflict. So you could name a file main like this, and you can get past this, sure. But what this does is it basically just provides an interface, that isn't easily overridable, that you shouldn't really ever need to overwrite. And if you do overwrite, it'll probably cause problems anyway. To provide a check so that, if you are intentionally running this file, that's essentially what this line is saying, then do all these things. And this is good for testing. It's good for, it's good for scripts in general, really. But yeah, so that's what that does. It's a very simple, very short explanation. There's not really an awful lot to it, but it is incredibly useful to know. and you should be using it in every script that you write. If you write Python packages and you need to do certain debugging things, you can do this and then just have this in here. And then when you test them somewhere else, it doesn't matter. And then you can either remove this or you cannot remove this, depending on what you want to do. But yeah, really useful, really easy, and just overall a no-brainer. So that is, well, really all I need to do. There are many things in Python that are overlooked and not used enough and not given enough love. And the collections module is probably right up there with the most useful things that are the most ignored. And it's weird because it has so much good stuff, and I'm going to be showing you 3 things you can do with it today. But it's so very useful, and it's almost like no one has even heard of it with the amount you see it around. You just don't ever see it. And I'm here to change that. So we're going to create a file, and we're going to call this named tuple. So I'm going to be showing you how to use a named tuple, a deck, and a default dict. These are the 3 that I just find most useful. I think there are 5 or 6 more things you can do with it. But I'm just going to show you these 3 things so as to not spend all of your time. You can do your own research into other stuff if you want to. So we're going to be doing a named tuple in this file. So this is sort of a read-only object. It works like a tuple and an object at the same time. Attributes can't be changed once they are set, so it's good for that sort of thing. So if we were to have, for example, a full name class, and then we give it a named tuple, and then you have to give it a type name. I always recommend just setting it to the same as the variable name you set for it. And then in brackets, or it can be in a string, but I prefer to do this, you can have first, middle, and last. And these will be the tuple elements. So the tuple will be comprised of 3 elements, and you'll be able to use dot accessing to be able, like you would an object, to be able to access these things individually. So if I were to do my name equals full name, and as we all did this last take as well, as we all know, my name isn't in fact Ethan, it's Barney the dinosaur. We can do print my name index like that, and we can also do print my name dot first, and it will do exactly the same thing. So as you can see, we've accessed it by index, and we've also accessed it by dot accessing, and it's done exactly the same thing. And you'll note that if we try and change anything, so if I wanted to say it to, I don't know, Garfield, because Garfield isn't a dinosaur, it won't let you do it. And that's the exact reason it won't, specifically because Garfield isn't a dinosaur. It also, well, I've lost my mind already, and I've only just started recording. If we try and do it using dot accessing as well, it will do exactly the same thing. Well, actually, we need to show that off. We need to comment this out. But it will do exactly the same thing. It says it can't set the attribute. And also above it says full name object does not support item assignment. It's actually a different type of error. That's weird. I actually didn't know that. But yeah, essentially it is a read-only class / read-only object. It's very useful for certain things, especially if you've got maybe like an API call and there's a lot of data, and you don't necessarily want to make a full class because you think it's a bit of a waste of time. You could just use it as a full tuple and just iterate through things like that, and it's really nice for that sort of thing. Arguably even more useful are decks, spelt weirdly. So we do from collections import deck, and these are essentially lists that have fixed maximum lengths. Well, I think it's optional actually to set a maximum length, but you can also insert and pop things from the left as quickly as you can from the right. It is essentially a double-sided limited list of things, and it's really an extension of lists in that respect. So you can have a deck of numbers, so you do need to pass it an empty list to initialize it, or you can actually pass a list that has things in it if you want to. And we're going to set the max length to equal 5. So that means the deck can be no longer than 5 elements. Once, if you append an item to the end of the list, the first item will automatically be popped out of it. So it's not like it won't accept any more arguments. It will just, get rid of the the first argument. It would be first in, first out. That's the one it is. It's a first in, first out. There are other things around if you want Philo, first in, last out. We can do for I in range 10. I might cover those in a future video. We can do numbers.append I, and then we can print the numbers. And then if we do this, I'm starting to regret doing this naming scheme. But you can see it's appending things as it goes, until it gets to here, and then it realizes, oh, I've already got 5 elements. I will pop the 0, so you can see the 0 is now gone and the 1 has moved over here, and the 5 has been added, and it essentially just kind of cycles through like this, and it keeps to 5, but it keeps appending things at the end. So that's one really good use for it. Another really good use for it is the whole append left and pop left things I was talking about before. So we could, if we wanted to, put the number 4 back on the left. And then we can print numbers. As you can see, the number 4 is back on the left, and the 9 has been popped off the right. Because you're appending from the left, things get popped off the right when the maximum length has been reached. We can also do pop left and then print n, and that will now print 4, because 4 was the leftmost element. So we're now popping from the left, which is something you can't normally do in a list. If you wanted to, appending is just append, popping is just pop, exactly the same. It is an extension of lists in that respect. It works exactly the same with indexing and everything. It's just, it provides more options. Essentially means you don't have to have some constant with if statements to determine maximum lengths of things. The final thing that I want to show you today is default dicts that are, I would argue, about as useful as decs. It sort of depends exactly what you're going for. If I can find my notes, there we go. So from collections, import default dict, and then we can set a collection of items as a default dict, and then in here we have to pass apparently we don't have to, but we can pass a factory method in here. So I'm going to pass list. So this items is now a default dict where the starting element, or the default element, is an empty list. So what it does, normally if you were to try to update a variable update a value of a key in the dictionary that doesn't exist, it will, an error, and it will complain. However, with this, if you try and update an element, then it will automatically create an element for you using this default. So in this case, it could be a list. If you wanted it to default to an int, you can do it as an int. It does have to be a method, and this does mean you can put, lambdas in here. So you can say, we'll talk about I'm getting ahead of myself. We'll leave it as a list for now. I will do items, and then we'll just have my items, for example, and say that I acquired, I don't know, views as an item. I don't know. And then if you print items, now you notice that we never actually set Ethan to be a key of the dictionary. Never tell Python at any point to do it. And we also never tell Python to set it as a list. However, because we set it as a default dict, it knows. So you can see we have my name, and then we have our list of views. And if we were to have, say, an int, and then we do plus equals 1, for example, we now have 1. And the thing with lambdas I was saying before, we'll just use a number again. So lambdas, I'll do a separate video on lambdas. There's no point in talking about them now, but they're essentially anonymous functions. So you can set, in this case, lambda 7, and now the default will be 7, and because we've added 1, it's 8. So this function is basically, returning 7. It's sort of like doing def factory return 7, essentially, and then putting that in here. It's the same thing as doing that. It's just a bit nicer to do with lambdas, because it makes a bit more sense. But you can pass any function you want in there. It can be as complicated as you like. It can have all sorts of validations and everything. You wouldn't necessarily need it if you're just doing a default value, but you could do whatever you want. You could literally have a dictionary where the value just assigns itself at random. Just complete randomness in there, which I think is quite fun. Obviously, it's not too practical, but the point stands that you can pass in any method in there and it will do it for you. So that is a general rundown of the things that I find most useful. In the last video, we talked about collections, a module that doesn't get enough love in Python. In today's video, we're talking about enums. Now, it gets a little bit more love than collections does. It's a little bit more well known. That it is very useful, and people don't use it when they should, really. So I want to just make people aware in case they didn't know about it, and hopefully you'll learn something new, because there is actually something I learned fairly recently about enums in this video as well. That's actually a really cool thing and a really cool way to use them. So we're going to create a file just called enum.py, and we're going to do from enum import enum. This enum is something that classes inherit. So you would have, say, a separate class, maybe state, and then it would inherit enum like this. And what you do here is you just pass class attributes to certain values. So if you were to do a game, for example, we might want to have a playing state, which we'll just set to 0, a paused state, which we'll just set to 1, and a game over state that we just set to 2. In some instances, the actual value, so the 0, 1, and 2 in this case, won't actually matter. In some instances they will, but in some instances they won't. If they don't matter, what we can do is you can import auto as well, and you can have this auto here, and it will basically just make sure that the values are unique. It doesn't necessarily matter what they are in this particular instance. All we need to determine is whether we're playing, paused, or game overed. So we can just set this to auto, and it will automatically select a value that is unique. And then from here, we could just do print state.playing. And then we do enum tuts. And then it just, prints the state.playing. This is simple enough. This is more useful if you had, say, a state variable, which is state.playing. And you would if state double equals state.playing, and then do the logic. This is where it would work. Let's actually see what the value of it would be when it's on auto, because I don't know what it would pick. It might just pick 0, and it'd be helpful if I actually printed the value. That'd be that'd be great. Oh, it picked 1. Okay, that's fair enough. It picked 1 in that case. But yeah, it always prints something unique it always chooses something unique. Does it? It's always 1. For each of these things. So that is a really simple, overview of enums. I'll put that if statement back just for the people who didn't see it before. There we go. Oh no, that's not what I wanted to do at all. There are more complicated ways of using enums, but this, they really are that simple in concept. And you may have some other uses for them. And in this, I actually want to show you a real-life example of an enum that, well, I say I created. It was contributed, but it's used in one of my now slightly abandoned libraries. I haven't updated it in a while. And it is this. So this is a message type. So this is an API wrapper for YouTube chatbots. And each message in the JSON has a message type. And it can be any one of these. And we have, the actual constant key here and the variable here. So this is how it appears in the API. And one really cool thing you can do is if you get, say the value from the API, say the value is chat ended event. And you can do message type and then initialize it with this value. And what it would do is it will then print the enum variable for it, which is actually really cool. I didn't know that was a thing for ages, and I just experimented with it thinking, oh, maybe this will work, and it actually did. And it was really cool. So I just thought I'd show it off for other people that didn't know about that. But this is one really useful way of using enums. You may be asking why not just have this value here. The answer is enums are just good practice. I like enums. I suppose in this particular instance it would be preferential. There are other ways to do this. But enums just provide a clear, clean interface for this sort of thing. And I don't know, I just like them. But yeah, that's pretty much it. If you like the video, then hit the like button. Data classes are a bit of an odd one. Some people watching this video will see what I'm about to do and think, I've seen something like that before. Isn't that something you can do in Itertools? Because there is a Python package index module called Itertools, which does a lot of the same things. It's actually a little more powerful in some respects. However, data classes are an inbuilt part of Python. I personally prefer them. Other people personally don't. So it really is your call, which you use. I just find Itertools really clunky for some reason, and data classes I just find really nice. There is actually an optimized data class that I was going to do in a future video. I was going to do a video about a while ago and completely forgot. But that's a future video. For now, we're just going to talk about the one that's inbuilt in Python. So we're going to do, we're just going to call it dt.py. I'm getting lazy now. And we're going to do from data classes, import data class. And then we're also going to import field. And I'll talk about field in a second. So a data class is a class wrapper. So for those of you that don't know, decorators can wrap classes as well as functions or methods. So we can now do, say if we wanted a profile, we now do name as a string, age as an int, gender as a string, and jobs as a list of strings. So essentially what we're doing here is we are telling the data class that we want name, age, gender, and jobs to be, instance attributes. And we're saying that they should be of type string, int, string, and list of string, respectively. And you do actually have to do this, otherwise Python syntax will complain. Type hinting allows you to do this. If you don't do type hinting, it won't let you do it. Unless you use a field, but then I think MyPy will complain at you if you don't. But it's whatever. And with this, you have now created a class. You have created a class with an init and a wrapper. So if we just set a profile to be a profile of my name, my age, my gender, and my jobs, which is nothing. I'm unemployed, lol XD. And then we're going to do print string well, actually, you know what we'll do? We'll do a profile and then the actual wrapper. And then if we run that, we can see that our profile has a name of Ethan, age of 23, gender male, and jobs nothing. We've done all that in this. So we've created our inits, we've created our wrapper. If you just print it as a string here, it does exactly the same thing. And it's such a time saver for these sort of things, but that's not all it can do, because it can have keyword arguments as well. So if you were to set, say, a keyword argument for gender to user specified, this is what Google refers to as its non-binary, I'm pretty sure. So we'll just use that as the default, because why not? And our jobs, we could set as an empty list like that. However, there is a problem with that, and this is one of the weird quirks in Python. That this essentially is stored in memory, and then every time you use a class, it will use the same list. So if you ever append to this, so if you create a profile, and then you create, say, a profile 2, and you append to the list in profile 1, you'll also append to the list in profile 2. It's a weird quirk in Python. It's very bizarre. It's why you don't have mutable keyword argument defaults, because they're resolved at essentially boot time, not when it's called. Very weird, very strange. One way around it in data classes is to use the field and then set a default factory to list. So those of you that watch the collections video with the default dicts will kind of recognize what's going on here. So essentially, when a profile is initialized, if nothing is provided, it will use this method here to determine the default value. And yes, you can have any functional method there, and it will work just fine. In this case, a list creates an empty list. So now it creates a separate empty list for each profile. So we can get rid of these two now. And we can see our gender is user specified, and our jobs are still none because we're still very much unemployed, which is grand. So we have our keyword arguments and we have our non-keyword arguments. So at this stage, I want to show you what this code is equivalent to. And it is, if I copy it from here, at least it's functionally equivalent to this. Oh my god, that did not help at all. Can I move that out? There we go, that sort of works. So it's not syntactically equivalent to it. You know, this jobs is handled slightly differently. It can accept a none and then you do jobs or none. This handles the, you know, the mutability problem. But you know, instead of creating this whole init with all of this stuff here and sending everything in and creating this repr like manually doing absolutely everything, the data class does all that for you. There are plenty of other things that this can do. So if I get rid of this for a second, just so we can, you know, clear up the namespace a bit. I'm not going to show you absolutely everything because we'll be here for a while, but I do want to show you, you know, at least make you aware of the most useful things. So if you want, you can also import, you know, keyword only. And if we were to say have this like this, so you have this underscore and then you type hint it as keyword only, what it tells the data class is that gender and jobs should you know, are keyword only arguments. So it still works like this, but if we were to do say something like this, it will say that it you know, it takes 3 position arguments before we're given. We have to provide it like this, otherwise it won't work. Some other cool things you can do reside in here. So from Python 3.10 onwards, you can set slots equals true, and it will automatically generate slots for you. Now, I'll talk about slots in a separate video as well. That would actually be a good one to do, thinking about it. But for those of you that know what slots are, you can do that. You can also set frozen equals true. So once the profile is created, you cannot change anything about it. It's sort of similar to the name tuple in that respect. And then one slightly weird one you can have is init equals false, which disables init creation, which is useful if you want to, you know, have your own custom init and you just want to have, you know, an automatically generated repr. That really is what data classes are for automatically generating representation string, you know, dunders. But if you want to have your own custom init, then you can turn the init off. I believe you can. Oh, don't quote me on this. I believe you can in the field turn init. Yeah, you can turn it to false. So now jobs isn't set in the init, and you know it does it somewhere else. I'm not entirely sure. I've never, you know, found a use case for that. I'm not really sure where you would do that. But, you know, it's an option if you want it. Yeah, I think I've covered enough of the basics of data classes. You know, there's a lot to this. It's worth looking up. It's also potentially worth looking into attrs as well, if you like the idea of this. Attrs is the same thing, just a bit more powerful, and it also supports Python 3.6. I personally don't like it as much because I just feel like it's really clunky. I've never gotten along with it anytime I tried to use it, but you might have more luck than I do. So if you do, let me know. But yeah, if you like the video, then leave a like to let me know and comment below. Slots are another one of those really useful things in Python that are criminally underused. Not an awful lot of people have heard of them, and if you have seen it before, you might be a bit confused as to how they actually work and what they actually do. This video is going to show you how to set them up, what they're used for, and how specifically they're useful. So we're just going to create a class. We're going to do another profile, sort of like what we did in the data classes, I suppose. And we're going to have our init that takes, you know, self. I'm just going to have name and age. We don't really need anything else. And then we can do self.name equals name and self.age equals age. And that is a perfectly normal class. What we can do is we can create a profile of profile, and then we can pass in my name and my age. And that works perfectly fine. However, what we can also do at this point is we can say profile.gender equals male. I am a male, therefore I am a male in my profile. I can then do print profile.gender. And despite it not really being a thing in the class itself, gender is now an attribute of it, and we can now print it out. So you can see it's printed out male here. This isn't necessarily desired behavior in a lot of instances. So what you can do is you can implement slots. So slots are a dunder class attribute. So we define them up here. We can say slots equals this, and it is an iterable. So it can be a tuple, it can be a list. It doesn't really matter. I normally set it as a tuple because tuples are a little more lightweight. And what we can do here is we can define the names of the attributes we actually want to be part of the class. So we can have name and age. So now profile accepts name and age to be set. However, it does not accept gender to be set. So now if we run it again, it will say profile object has no attribute gender because it's not defined in the slots. So we are defining the attributes. This doesn't lock down methods. You can still add methods to the class as much as you want using this method, but it just means that you can't do something like this where you're adding another attribute. If you did want to add another attribute later down the line, you could have that, and now it can be set. However, you would probably want to do something like self.gender equals like male or something here, and then you would set it later down the line if you were to do that, just for readability sakes more than anything. Slots aren't just useful for gatekeeping and trying to keep a little bit of control over what attributes are actually assigned to your object. They also significantly lighten the object down, because without slots, Python creates a dict for it. So if I just if I comment out the slots for a second, you'll see what I mean. So if we get rid of this too, get rid of all this as well, and then we can print, I was doing it right before, profile dot and then double underscore dict. What this does, it has a dictionary of all of our things. If we then do profile dot gender equals male, and then we print it again, I just realized I didn't copy it beforehand, that it's now added to that dict. And every class has a dict like this. However, if you define slots, this actually overrides the dict. So we can actually now run this again. It will give us an attribute error because it doesn't even have dict available anymore. But it does, I would believe, just have slots, I'm pretty sure. Yeah, so it has the slots there. So in not having this dict, we do two things. One, we save on memory because there isn't a dictionary object, which is huge. I can actually demonstrate that now. So if I were to comment this out again, and if I do print, I think it's like dot size of or something. Is that correct? No, it's not. Oh no, hang on, because this needs to be dict. No, it is correct. There we go. So our dictionary is 88 bytes in size. Obviously in a bigger object, and with a lot of objects, that's going to stack up. However, our slots, which contains all the same things, is only 40, so it's less than half the size. So our class is now half the size. Editing me here, just wanted to jump in because I misspoke a little bit here, and I just wanted to clear it up because I knew someone would comment about it if I didn't. To say that the object is less than half the size isn't technically accurate. That's not taking into account, other attributes and everything. The actual object is the same size, but the size of the object that you get given by Python isn't the actual size that it takes in memory. It's a bit of a weird quirk, but the object is the same size, but because the dict or the slots are attributes of that, and those are different sizes, the object takes a different amount of memory overall. But if you were to query the profile.size of, it would return the same number, which I believe is 42 bytes or 40 or something, I don't remember. But I just wanted to clarify that. Otherwise, people will comment about it, and it was a bit of a confusing statement. So sorry about that. I'll get back into the video now. The other thing we're doing is we're actually speeding up the creation of the class itself. So to demonstrate that, what I can do is I can import timeit, or actually we'll do from timeit, import timeit. There we go. And I will have, we'll comment this out. And then we'll do, so we code equals that. Oh, God. There we go, code equals that. And then timeit, let's see what it is. So statement is just the code. The setup, we don't need to worry about in this case, I don't think. I really hope we don't need to. And then the number equals, say, 10,000. So we're now going to create 10,000 classes, and then we're going to print the time it took to do that. Okay, so yeah, what we need to do is we do need to do the setup. So if I do setup, it's always a bit awkward using the timeit, I find, but it is a useful tool. I might do a more advanced video on it. Oh, for God's sake. Are you kidding me? Okay, there we go. I managed to get it sorted out. Right, if we have 100,000, maybe that. Yeah, so 0.02 if we don't have the slots. If we do have the slots, it comes out to... Okay, it's a little bit quicker. Let's see if we can get a better indicator. 0.19 with slots. 0.19, 0.19. If we then comment this out, 0.24, 0.25, 0.25. So you can see it is consistently slower. It doesn't appear to be that much slower in this case. However, it is a very small class with only 2 attributes and no methods at all. And there's also only one of them. If you're making a game or a bot or something that needed to be memory efficient and time efficient, and you were going to be creating a lot of classes, then having this memory saving of even just a small number of bytes, when you multiply that by 1,000,000, that becomes millions of bytes. So you can see when code starts scaling up that it's really good to be using slots, especially if you're building like a game, as I say, or something like that. Other than that, if speed isn't necessarily a concern, I can't speak at all today apparently, then it's still useful for doing what we did before, in making sure that only certain attributes are actually created. It's also just good for readability, I find. I quite like slots being there just so I know what's there and what's not. Sometimes inits can be really complicated, and just having that there is just really nice. But yeah, that's pretty much everything I wanted to say on slots. If you found the video... I'm sure many of you watching this would have seen something like this out in the wild, or potentially have even done it yourself using context managers and this with statement. This particular one is opening a file as F, and then reading the file and printing it out to the console. It's pretty simple. If you've never heard of context managers before, or have never seen that with statement in your life, then I do have a separate video which will be in the cards if I remember to do it, that goes over the basics of context managers and how to use them in a little bit more detail so you can get caught up. This video is going to be focusing on something different. In this video, we're actually going to be learning how to create our own context managers. You can create a context manager out of a function or a class. We're going to start with classes, and we're going to move on to functions. And to give an example, I've recreated the open slightly. I felt like file operations are probably the easiest and the most effective way to convey what I'm trying to say here. So we're just doing a file object. This one is one I prepared earlier in the oven, 200 degrees. We have our init, which takes a path. We can then open the file, close the file, and read the file. We can't write to the file, but we can do everything that's important for this example. So to work with the object like it is, we would need to do something like file equals file and then hello.txt, which is our text file. Then we need to do file.open. Then we need to do file or print file.read. And then we need to do file.close. And we can see if we load the terminal and run the program that it does open and read the file, and it closes the file perfectly fine. However, this is a little bit clunky and it's a little bit cumbersome. But with context managers, we can actually make it a little bit nicer. So if we just get rid of all this for a second, and then we come back into the class, and then we create 2 new dunder methods. Dunder enter, which just takes self. And in most instances, you would want to return self. You can actually return anything out of this if you want, but in about 99% of instances, you would want to return self out of this. And then we want to do exit as well, which takes the exception type, exception value, and exception traceback. We'll come back to that in a bit, and we'll just leave that empty for now. So this enter is called, if I just load the example back up again, this enter is called whenever we enter a block. So on this with open line as F, in this example, the enter is being called. The exit is called when you exit the block of code. So down here, if I were to say, print hello, at this point in time, the context manager has exited. This exit, method has run, and we're now outside of our context block. And this allows us to do some pretty cool things behind the scenes in terms of things we would want to be able to do. So in the exit, for example, we want to be able to close the file without having to explicitly say to close the file, and we can do that. That's what the open does. So if we just go into the enter real quick, and we can just print in here let's do entering context. And we can just use self.open. You know, we already have an open thing here. We don't need to rewrite anything fancy. And then we just do self.open, and then we return self, and that's fine. At this point, we can actually use the context manager as a context manager. So we could do file, or with file, hello.txt as f, and then print f.read. And we end up with the same result as we did before. So you can see we're entering the context, we're reading the file, and then we're displaying onto the console. But now we're only using 2 lines instead of 4 when it actually comes to reading or opening and reading the file. In terms of closing, what we can do is simply just do the same thing here. What has happened there? I did not tell it to do that. Exiting context. We'll just put that in there for debugging purposes. And then we can just do self.close. Exit doesn't need to return anything. I don't think... Oh, it can return something. We'll get onto that in a bit. As you can see here, so we're entering the context. We're now displaying the contents of the file. There's a new line here in the file. And then we are exiting the context. You know what? To make it a bit clearer, I'll do that. Just so it's a little bit less confusing. So that's just a really basic idea of how context managers work. There are a few extra things that I want to show you with classes before we move on to functions. The first of which is actually utilizing these. So the exception type is the class of the error. The exception value is the instance of the error. And the exception TB is the traceback object associated with the error. We're not going to be touching this today. We're going to be looking mainly at the value. So I have a separate file here on the side called jank. And this has just a single character. It's a byte string /x9c. Character, which cannot be decoded in a Unicode file format. So what we can do, if we try to read that file, we'll get an error. So what you can try to do when I actually get the sentences in the right order is do if is instance exception value, and then we can say Unicode decode error, and then print that file cannot be read, or I guess whatever that'll do. And then if we run it on the hello.txt, we'll see it's still perfectly fine. But if you run it on the jank file, we'll see that we get the error. But we have our entering context. That file cannot be read. Exiting context. So we exit the context. So this self.close has been activated. And then by default, Python re-raises the error to the top level. We can actually suppress that behavior. This returns none, normally. This exit returns none, normally, which is false in a truthy check. However, if we return anything that returns true in a truthy check, so we can do, I think actually probably the best way to do it would be errored equals false, and then errored equals true, because this way we can still close the file, and then if we return errored, then if the thing errors, then we actually do get to close the file. So if we return true, then we don't raise the error. So we can print this is a thing, and it works fine. So we've now suppressed the error. We've still sent out a message. We could replicate the error if we wanted to. But if I just set this to always be false, for example, then we can see that last line never gets printed because the execution of the program is terminated at that point. So those are things that I wanted to show you with regards to a class. This is probably in almost every case how you're going to be using context managers. You can actually do it in functions as well. I just realized my Pepe is off. There we go. You can actually do it for functions as well. I'm not convinced there's really a use case for it, but I'm going to show you it anyway, just in case you find one. So we're going to create a new file here. If I just load my notes, so I can remember. So we can do from contextlib import context manager, and this is a decorator. So we can attach a decorator onto here, and then I'm going to do some more opening of files because again it's the easiest. And we can do open file path like that. And if we just do this for now, I can explain what's going on. This context manager decorator adds boilerplate in some way or another and activates our enter and exit, or applies enter and exit logic for us. I don't quite know the background of how that happens, but it allows us to use our with on a function, which is actually probably what the open built-in is doing. So I guess that's the use case for it. But in terms of stuff that isn't built in, I'm a little bit less convinced. But we can do print entering context. And then we can do f equals open, so we can use the actual open path. We can try and yield f, and I'll explain why we use yield in a second. And then finally, we can f.close. So we're just making sure that the file gets closed when we're done with it, regardless of if there's an error or not. And then we can do print exiting context, like that, just so you can see what's going on. The reason we use yield instead of return is because the context manager or Python needs to be able to re-enter this function once we've done what we need to do with it. If you return it out, it will error. I forget what the error is, but it will complain that it's not a generator and ask you to use yield instead, more or less. So you do actually need to use yield here. You cannot use this like a generator though, so you can only yield one value out of it, which is why I'm kind of the opinion it's a bit odd. But I thought I'd include it anyway for completeness. So we can do with open file hello.txt as f, and then we can print f.read, and then if we do where is it, func.py, you see it does exactly the same thing. We have the enter in context, the exit in context, we read the file, and we do all that. If anyone can kind of figure out outside of the open built-in why this is useful to anyone, then please do let me know, because I'd like to know if it is useful, because maybe I can use it in some of my stuff. But that is the basic idea of context managers. It's a little bit of a longer one than I've done in recent times, and it might be a little bit more complicated. There is a very real chance that you've used a generator before in Python, perhaps even without knowing it. A lot of the Python standard lib is built on top of generators, and this whole idea of lazy computation or lazy iteration, which is what generators fall under, is really kind of a core concept of Python in a sense. It provides a flexible way to create potentially infinitely long series of values that don't take up a potentially infinitely large amount of memory. And that's because generators, as the name implies, generate the values in a sequence as and when they are needed. It's not like a list or a tuple where all the values need to be put into memory at the time that the thing is loaded, or the list is loaded or whatever. Generators only use the memory that they need to use at the time, because they only generate values as and when they're needed. I do quickly want to say that today is the 3-year anniversary of the channel. I've been doing this for 3 years. I haven't got anything special planned for today. Hopefully I'll get something done next week. I'm actually moving out of university this week. So everything is just kind of up in the air. I just didn't really have the time to do everything. As you can see, I've reformatted back into Windows 10. On top of everything else, so there hasn't really been any time to do anything special, but hopefully I'll have something next week for you. But in the meantime, generators are a really important concept in Python, and I'm surprised I haven't done a video about them yet, so I'm doing one today. So I said at the start that you may have used generator without realizing it. If you've never heard of generators before and you've used range before, not ramg, range, then you've used a generator. If I do for I in range 10 and I do print I, we can see that it runs perfectly fine. But if we then do just range 10, we can see that we just have a range between 0 and 10. It doesn't print a list or anything. If we print the type of it, it is a class of range. Now range is a specific thing. It is kind of a class in and of itself, but it acts very much like a generator insofar as the numbers are generated as and when they are needed. Hence, you can have, range stupid levels, like stupid numbers, and this will just work. I'm not gonna, leave this to run, but we're not using any additional memory generating any of these numbers at all. We haven't loaded however many numbers this is, I don't even know, into memory, otherwise the whole thing would just crash. Instead, we are generating each and every one of these numbers as and when we need to, which is how we can get away with having these infinite sequences, as I say. Creating a generator isn't even that difficult. It kind of relies on already existing syntax. So we actually create a function to do it. And in this case, we're going to create, a function that starts from 2 and returns the previous number doubled every single time up until, n number of iterations. So we're going to do double and we're going to do n. And I'm just going to do kind of, so v equals 2. And then for I in range n, yield v, and it would be times by 2. And then actually what we can do is just kind of do v times equals 2 and then yield v. That'll probably be easier. So what we're doing here is we're just setting v equals 2. Actually, we can probably set it equals 1, to be honest. And then for, the number of steps that we say, we multiply the current value by 2 and then we yield it. So this yield is the generator equivalent of a return. And this yield kind of turns the function into a generator itself. So all you need to do is supply a yield. And what it does is when this yield is hit, it sort of returns the value back out into the rest of the code, but the execution state is saved. And then once you go into the next element, it then runs through this again up until it gets a yield. So you can have a yield in the middle. I think there was a video recently that had to use a yield. I don't remember which one it was though. But you can have a yield in the middle of a function. You can have a yield right at the start if you really wanted to. But this yields, as I say, saves the execution function and then or saves the execution state of the function and allows you to iterate through it. While trying to play on this video, I kind of realized that I should yield the 1 as the first element really first. So it now yields the 1 and then it goes into here and then yields everything beyond that. Again, this is perfectly fine. You could just have multiple yields in a function and it will work just fine. There are multiple ways of accessing the next value in a generator. So the first of which you could just use the next built in. If you ever wonder what this does, then this is what it does itself. And then we can have, say gen equals double 5. If we just print gen for a second, actually, before I go into this next thing, you can see that it prints a generator object double. So this is our actual generator object. So you can see that nothing is loaded really into memory. All we have is the actual generator function itself. We can't actually access individual elements. If I tried to access the second element, we wouldn't get anywhere. It's not subscriptable. What we'd need to do is we need to use this next to actually access the next element in the array. And then we can do this multiple times, and we can see that we have 1, 2, and 4. So once a value is consumed, it is lost. Unless you save it somewhere else, it is lost. And then this next would then call, so the execution state would be saved here after this one. After this one, it would then move into this for loop, but it would be saved here. And then once you run this one, it will go back into this for loop and then it will keep going and it would, run this again and it will just kind of do this forever, really. The other way you can do it is by doing, say, for I in range 5. We can do, actually, no, it'd be for I in double 5, sorry. No, I didn't tell you to put a capital there. And then print I. Do that as it will print 6 elements. That's interesting. Oh, because this needs to be n-1 now, doesn't it? There we go. So it now prints 5 elements. If we did this with 10, it would print, our 10 elements. If we did this with a stupid number again, then it would start printing out, very ridiculous numbers very quickly. I'm going to stop that before it has a bit of a heart attack. But you can see, again, we're not loading all of these values into memory. We're generating them as time goes on. The other way to do this is by using something called generator comprehension. Now, I don't actually remember if I've done a video on list comprehension or not. If I have, it'll be up in the cards. If I haven't, then there'll probably be a video on the channel quite soon about it, because I feel as though I should have done it if I haven't. So, I'll make good on that if I haven't done it yet. But generator comprehension essentially works the same as list comprehension for those of you that know about it, except instead of using square brackets, you use normal brackets, or if you're in America, parentheses. But other than that, they are pretty much the same. And a common use case, or at least the most common use case I can think of right now, is when using the any or the all built-in methods. You can create a generated comprehension that essentially evaluates a series of values and then kind of yields the Boolean, whether it's true or false, and then you can pass that into any or all, and it will do the rest of the computations to make sure that everything's fine. What you can do, say for example, is I modulo 2 double equals 0 for I in range 20, and then if we just say this is like gen for now, I suppose, and then we print gen and we actually comment this out so we're not getting annoyed, you can see there is just another generator object because it's it doesn't have a function name. It's just called genExpr or generator expression. I'm not even sure if it's called generated comprehension officially. I just like calling it that. I find it quite fun. But we can see that if we do, next gen, and the same thing again, is it true, false, true? It works exactly the same way, essentially. So we can do for I in range gen, print I. Generator object cannot be interpreted as an integer because it's not a range, it's just a gen. And we can see, true, false, as you would expect with, something that checks if something is even or not. But in terms of the actual use case I was suggesting, what you could do is, if all, and then have this in here. And you don't even need, parentheses or brackets around this. Print true, else print false. As we all know, this is going to print false. But if we just get rid of this, so you don't actually need brackets around this bit at all. You can just have, your all and your expression in here, and Python will default to a generator expression. If you wanted it to be a list comprehension, then you could do it something like that, and then it will work the same. But if we run this now, then it will say false because obviously there are odd numbers between 1 and 20. I suppose it would be between 0 and 19, wouldn't it, in this case? But we don't need to get bogged down with the specifics of that. So that is basically everything that I wanted to talk about generators. As I said, they are incredibly useful. You've probably used one or two of them without even realizing. And if you haven't used them before, then you really should be using them because they are just great. They are fantastic in all sorts of ways. Of course, if you like the video, then consider liking to let me know and maybe subscribing. So I was looking through past videos of mine to see what I had and hadn't covered. And I realized that I hadn't talked about comprehensions yet, which is really weird because I would have thought I would have done that by now, but here we are, we're doing it. Comprehensions are a very cool thing in Python, a little bit of syntactic sugar, and they allow you to create lists, tuples to an extent, sets, dictionaries, and generators very easily, and it's a one-line syntax, but you can spread it across multiple lines as well. Tuples, the syntax is a bit different. You have to do a generator comprehension first and then convert it into a tuple. But we'll get into why that is in a second. So the general rules are the same. Well, apart from dictionary comprehension, the rules are generally the same. Where you have your list here. So if you say evens, for example, we'll just have a really basic example. For every number 1 to 100, we populate a list with even numbers. And we have our list brackets there. And we can do I for I in range, say 100. If I modulo 2 double equals 0. And this is a standard even check. If you divide it by 2 and there's no remainder, it's an even number. So that's why we're doing that. But as you can see, this is our one-line setup. For those of you that don't quite follow what's going on, essentially the order of operations is for I in range 100. If I double equals 2, insert I into list. So it's sort of like if we had, say, evens equals an empty list. We have for I in range 100. If I modulo 2 equals 0, then we just have evens.append and then the I. Except this list comprehension up here is a lot quicker because we're not calling append every single time. And calling append is slow. One, because just appending to a list is slower than normal anyway, and two, because it's a function call, and function calls in Python are notoriously not very quick. So being able to get away with not doing those is where we get the additional speed ups from this. So to just prove it works, if we do pi comp to pi, we don't print anything. I seem to always do that. I don't know why, and I'm always doing event, which is strange. But you can see you have a list 0, 2, 4, 6, 8, etc., etc., up until 94, 96, and 98. The exact same rules apply for sets, so we can just replace our square brackets with curly brackets. And because in Python a set notation is determined by if you have curly brackets and then don't explicitly create a dictionary, then you create a set. Unless it's an empty set of square brackets like this, in which case that would be classed as a dictionary, but this would be classed as a set. So it's able to infer that you want to create a set, and it does set comprehension. In this instance, the set is actually created in order because of just the way it's been compiled. I believe it's always in order if you do it like this, but don't quote me on that because I'm not 100% sure. That might be a new thing. I know in Python 3.8 they updated orderings of things, but I'm not sure if that was limited to dictionaries. So do let me know if you know whether that could return something unordered, but as far as I've tested, it always returns something ordered. Now, the reason we can't do tuple comprehension straight up, and we'll come to dictionary comprehension a bit later, is so if you have brackets like this, if you watch my previous video on, I forget exactly what the topic was already, it's been a while since I recorded anything, but this generates a generator rather than a tuple. So if you were to print this, you can see it's a generator object, and then we would actually, if we just do next evens like that, we can see we get the 0. And then if we print, I think it might have actually just been non-generators the last video completely. And then, we have 0, 2. So it works exactly like a generator. But this is why you can't do it with tuples, because tuples, or tuple comprehension, quote unquote, like this, creates generators. What you need to do instead is you need to actually wrap this in another set of brackets and then have a trailing comma. So in Python, for those of you that don't know, that would register as just an int. The brackets kind of get removed during compilation, but if you do that, it's a tuple, because you're now saying that there could be multiple elements there, but in this case there's only one. So you're kind of providing an element break here, which is the same thing you're doing here. So you're now saying, oh, this is a tuple, not just something to ignore, and you actually need the star here. So in this case, you'd be unpacking your generator into a tuple. You could do it with a tuple inbuilt method as well, but it's slower to do it like that. So we don't do that. We don't like slowness here. Even though we use Python, we try and find ways to make it as quick as possible. It's a fun challenge sometimes. Now, dictionary comprehension works a bit differently, so I'm actually going to remove everything here. I'm going to bring up my notes on the other screen. A reasonable size, there we go. And we're actually going to create 2 lists. So I was kind of thinking of the best way to demonstrate this, and I think I've got it. Hopefully. So we have a series of numbers. We'll just have a list 1, 2, 3, 4, 5, and a series of words 1, 2, 3, 4, and 5, like that. And essentially, what we want to do is create a dictionary that maps a number to a word. So we want to map 1 to 1, 2 to 2, etc., etc. So what we can do is we can create, the same syntax we have with sets. So we do NW for NW in zip, whoopsie daisies, zip numbers words. So zip numbers words returns kind of a generator of tuples. So each entry will look something like this. For example, well, actually we'll do it like this. So each entry will do something like this. We then unpack that tuple here into separate N and W variables. So N will be set as 1 and W will be set as the word 1. And then we use, the standard syntax for a dictionary to actually create a dictionary entry where N is the key and W is the value. And if we do that, didn't print it again. There we go. So we have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. It's perfectly mapped and everything. I will actually show off a slightly different example for people that might not have quite realize what was going on. So if we go back to our evens again, actually, yeah, we can go back to the evens again. So we can do D, and then say I, and then if we want to map it to the square of that, so we could do I to the power of 2, for I in range 100, And then we can also provide if I modulo 2 w equals 0. So here we're doing the same thing as we did with the list generation and that. So we so for I in range 100, if I is even, essentially, we then set I as the key and the square of I as the value. And I'm going to remember to print it this time. Oh my god, I actually did it. And then the terminal does that, okay. But as you can see, we have 0024 416 636. So we have our if condition here, we have our loop here, and we have our key value mapping up here. So in a sense, it's not actually too much different from list or set comprehension or something like that. You just need to actually use the dictionary syntax for it to register as a dictionary. That's basically everything I wanted to talk about in this video. Generators are not too complicated to explain. They're, logically speaking, they're a bit weird to understand sometimes because everything's kind of in a different order. And if you've got a particularly complex generator, or not generator, comprehension statement, it can be difficult to piece together sometimes. The walrus operator does really help with it if you're in Python 3.8 onwards. So don't be scared to use the walrus operator with it, because some things are kind of impossible to do in comprehension statements without the usage of the walrus operator. So make sure to keep that in mind if you are working in Python 3.8 or above. If you like the video, then consider hitting the like button to let me know, and maybe this is... Recently, one of my personal projects has used asynchronous sockets in Python, and while I was trying to work out how to do this, I noticed that there wasn't really one clear way according to the documentation or any guides I could find. It was actually really difficult to work out exactly what to do with it. So I thought I'd make this video to try and help clear things up. I did eventually find this method somewhere, but I thought I would do something to make things a little bit easier to find. So we're going to do, if you saw the plan folder there, we're going to be doing an asynchronous server socket and an asynchronous client socket. And we're going to be doing local servers and that. Obviously, you would adapt this to whatever purposes you needed. I just find it's easier to do, local host server client setups just for demonstration, because we're going to be doing both of them in this video. So we're going to start with the server. So I'm going to create a new file called server.py, and we're going to import async IO. Now, the weird part about this is that we don't actually need to import sockets. Async IO just handles that all for us, which is quite nice. And then we're going to have our host, which is 127.0.0.1. That's our localhost one. And the port, which can be anything. I'm going to put 9999 because I know for sure that's not taken. And we need to define two functions here. So we need to define a handle echo. Yeah, I should say we're going to be building an echo server client setup. So we're not going to be doing anything too complicated. And that's going to take a reader. And for those of you that care about types, I am actually going to put them in just so it makes things a bit easier to understand. So that's a stream reader. And then a writer is a good stream writer, not another reader. No, not that either. God damn it, dude. There we go. And that returns nothing. And we're going to leave that alone for now. We're going to come back to that. And we're going to start instead with async def run server. And that doesn't take anything, and that also returns none. And inside here, we're going to define our server as await asynco.start server handle echo. So this is our awaitable callable. So the callable you pass here will be called every time the server receives some data. So I believe it's whenever a client sends a message. I'm not sure if it triggers whenever a client connects. I don't think it does, so keep that in mind. And then we're going to do host and then port. And then async with server, we're going to do await server.serve forever. I think there is a start serving, but I don't know under what conditions you would stop it in that instance. So we're just going to do serve forever because it's easy enough. You can stop it with Control-C. That works just fine. And we're going to do if name double equals main. So if this is the file we want to run, loop equals async io dot new event loop. Just a note, I'm on Python 3.10. If you're on Python 3.9 or 3.8, this would actually be get event loop. So just keep that in mind. And then we'll do loop.run until complete run server. It does actually make me wonder if run forever would work here, but whatever. I suppose it doesn't matter. And then we're going to come back to our handle echo up here. So right now we've got our server, that we start the server, it has a, it connects itself, or it binds itself, I should say, to the host and the port. We have our callables to handle things that we serve forever. We need to actually define the method, and we need to, provide a logic for when something is sent. So we're going to start by defining data equals none. You can define it as an empty string if you want, I suppose. And then while data does not equal some quit condition, so in this case we're just going to do quit. Obviously in your case it might be somewhat different here. And then we're going to do data await reader.read, and then we're just going to pass 256. If you think your messages are going to be longer than 256 characters, and you can do something like, I don't know, 1024 or 512 or something like that. If you're doing IRC, I think 1024 is the one to go for, because you have the IRC message, which is 512, and you have tags as well. I believe that's how it works. If you couldn't tell, the project I've been working on is IRC based, so yay. I might as well leave that at 1024 now. And then we're going to do message equals data.decode. And that's only because we want to print, actually we need to get the address first. So to get the address of the person that sent the message, we can do writer.getExtraInfo peer name. It's a weird one, but that does get the address, and that gets the tuple, so you get the IP address and the port. So we do print. Actually, what we can do is we could probably just do that, can't we? Just to make things a bit nicer. And then from addr, and then we can do our proper syntax now. So from address port, and then we're going to do message, and then we're going to pass in the string representation, so we get our little nice little quotation marks around it. So the only reason we're actually decoding the message here is to actually debug it. Obviously, if you want to, do some manipulation on data, you might want to. If you want to check data just to see if it has anything in it, then you probably don't need to. As you can see here, the byte string does, implement the comparability stuff. So you may or may not need to convert it. It kind of depends. I'm just doing it for example's sakes. And then to actually write data back, we do writer.write data. And again, we're just echoing the data back. So we're just, passing data straight through. That writes it to the socket, and that does it immediately, so that's not async. What you need to do after that though is do writer.drain, and this will wait to make sure that everything is clear before moving on to the next thing. And then if we get our data to be quit, then we do writer.close, and again on the same sort of logic, we have writer.wait closed as well, which will wait until the client is closed before actually shutting everything down. So this is our server implementation. It's a very simple server. Again, as I say, it's an echo server. Not actually too hard to understand, I don't think, which is quite nice. Async has a quite nice thing to it. So we can move on to the client, which is a little bit different, but not actually too much different. So this is kind of where I spent most of my time trying to work this out. This new method that I found is actually a lot simpler than the one I ended up implementing in my project, so I'm going to have to go back and change it. But we can import async again, and for our purposes, we're going to import time. You don't need to for socket things, but we're going to be sending messages at the time. So we're just going to do that, and then we're going to have our host, which is the same 127.0.0.1, and then we're going to have our port, which is equal to 9999 once again. So we're just going to have our single awaitable here, which is run client. And we're going to define our readers and writers in a different way. We're going to use await asyncio or asyncio. I knew I'd do it at least once. God damn it. Open connection host port. So this is kind of similar to socket.connect, and our start server is mainly similar to socket.bind. If you wanted direct comparables there. But yeah, our open connection, we just send a connection request out to where we want to connect to, and we get in there like that. Then once we've actually connected, we're actually going to send a message directly. So we're going to say hello world, and then we're going to do await writer.drain once again. And then we're going to do while true, data equals await reader.read, and then we're going to have 1024 again. And then if not data, raise exception. You can have your own custom exception here if you want. But the reason we're doing this is because generally speaking, if a socket sends an empty data, or if it sends empty data, that means it's telling you to go away, basically. So we're just doing this to say, you know, the socket is not necessarily closed, I guess, but, you know, it stopped communicating with the client. Or it could have closed. It does happen if the socket closes sometimes as well. And then we're just going to print received, and we're going to do some more log messages. And then data.decode. And then we're going to send our representation in there. And we're going to leave that for now, just to show off, you know, I'm actually going to get rid of the time for now because we don't need it just yet. But I want to show off kind of it working first, if I can move it over. There we go. So these are our two little things. We can bring up a terminal. We can actually split this terminal. And one of which we could do pi server.py, and the other of which we could do pi client.py. And when we connect to the client, oh, we haven't actually finished yet. That's my fault. We haven't actually run the thing yet. So if name equals main, loop equals async io dot new event loop, and then loop dot run until complete. And don't forget about the get event loop if you're on a different version of Python. Oopsie, this is run client like that, and now it will work. There we go. So you can see that we received a message here from 127.0.0.1 at port 56008 saying hello world, and we have simply, you know, just sent that message back, and the client has then received hello world on the other side. So that is the basics of how, you know, this all works. If you need a server implementation, you do something like this. If you need a client implementation, you can do something like this. I'm going to do a little bit more for example sakes, you know, just to show it off a bit. So on this side, we're actually going to set a number of messages to send. So we're going to send 10 messages before we send the quit. And then we do need to import time now, because we are going to import the time just to show things off a little bit better. And then if messages is greater than 0, because we already have the while true, so we don't want to do a for loop, otherwise we'll end up blocking our client socket. So awaits, we're just gonna, you know, sleep for a bit. async.sleep 1, and then we're gonna writer.write, and then we're gonna do time.time. So we're gonna send the time over to the server, and then we need to encode that. And then of course we need to do writer.drain, and then we, you know, because we sent a message, we deplete the number of messages, and then once the number of messages hit 0, we then write quit. So we actually send a quit command, and then again we need to do our writer.drain. And then I think actually we should probably shut the client down at that point as well. So now that we've got all that in place, we can run them again. So we can run our server.py, and we can run our client.py. And we'll see we start sending messages based on the time, and the server sends them back. So when we, you know, receive a message on this end, we receive a message on this end too. And then this, you know, it's now sent a quit message. So the client has shut down because we told it to, and this is now no longer listening for us. So, you know, we've closed the connection to the site. Actually, we probably don't need the break, because this actually literally closes the connection to the socket, which is kind of funny. I suppose it is on connect, because it then kind of listens for data and then runs it. Yeah, so this is actually gets called when you connect. I guess I was slightly wrong about that. So yeah, that's basically everything I wanted to talk about in this video. Lambdas have a bit of a reputation for being the thing that not a lot of people know what it is. It's very confusing, and that's probably in no small part because of its name. Lambda is not an obvious name insofar as it doesn't really tell you what it does. Guido van Rossum, or at least someone on the Python team, has actually gone on the record to say that naming this feature a lambda was a terrible idea. So what exactly is a lambda? What does it do? and how to use it. So a lambda, in short, is called an anonymous function. It is a function that doesn't require a name. So if I were to do def add xy return x plus y, and then if I were to do lambda xy x plus y, these two functions are completely identical. The main differences are that you use lambda instead of def. You don't need to supply a name, though you can do if you want to. And you also don't need to supply a return. Whatever's on the right-hand side of the colon is returned out of the function. If you wanted to give it a name, you could do something like add 2 equals and just define it the same as you would a variable. In order to prove to you that they are in fact the same, I'm going to give this a name, so add 2. And then we're going to do print add 1, 2. And then we're going to do print add 2, 1, 2. And you'll see this add 2 doesn't appear as, in the same color as a function. It's because it doesn't recognize this as a function, it recognizes it as a variable. But if you do run our thing here, we can see that they work exactly the same. This coloring difference is just, Visual Studio Code's linter. Don't be fooled by it. But yeah, they work absolutely identically. So you may be wondering at this point why you would ever want to define a function like this. You have this fancy one-line syntax using this lambda. Lambda's a very fancy word, coming across all very fancy. Well, there are problems with lambdas, or I shouldn't say problems as such, more that lambdas weren't designed to perform the same tasks as normal functions. For example, lambdas are not multi-line. You can't even use semicolons within lambda expressions. There may be a workaround for that if you use brackets. I don't know, I haven't tested it. So you can only do single line operations. So any function that needs multiple lines isn't going to work. There is a very specific use case for lambdas, and I'm going to show you what that is now. So say we had this list of animals. We have a dog, a cat, a bird, an alligator, and a shark. And say that we wanted to sort this list from smallest to largest by the length of each value. Now you could, in theory, theorize that you do sorted animals. If you didn't know any better, you could theorize this. And then if we printed that, what we'd find is that it sorts them in alphabetical order, because yeah, of course, if you were to sort a list of strings, your first guess would be to go alphabetically. So how would you do it using lengths? Well, the key, you see what I've just done in a second, is to use the keyword argument. See, there's so many keys in there, I can unlock several houses. So, and this key takes a callable. So something you could do is you could do def get len of string and then return len string, and then you could pass in get len in here. And every time, or for every element in animals, this getLen function will be called. The string, the actual animal will be passed to this string argument, and it will return the length of the string. And then, we return a list 3, 3, 4, 5, 6. You could add in extra logic to, sort by length and sort alphabetically. We're not going to worry about that right now. But that is one way that you could sort the list by length. And some people have just learned something new already in this video, and that's great. But there is an easier and more efficient way to do that. And it's to get rid of this. We don't want this. And instead, use a lambda. So what we can do is do lambda string len string. And now that does exactly the same thing. So because lambdas don't have to have a name, we can just define them right here in, as a keyword argument. And this is where the use case of lambdas lies. There are a few other things as well. So say if you had a list of numbers, actually, say if we still had the list of animals and we wanted to return all of them that were 3 characters long, we could use a filter. I'm just going to call this F for now. And then we can do lambda x and then len x equals 3. And then we can have animals. And then if we print the list of f, just so we kind of have a viewable representation, we can see that we've now filtered the list to only animals that have a length of 3. So we're using this callable as something called a predicate. And basically, if this function returns true for a particular element in the list, that element is then carried forward into our new filter object. So stuff like this, stuff like the key in sorted and stuff like the predicate in the filter are the use cases for Lambda. There are plenty of other use cases as well. Anywhere you need to pass a callable somewhere or a function, a lot of the time, unless you need a lot of logic within that function, it's going to be easier just to create a Lambda. So if you've got a single line thing that just needs to return a value and nothing else, Lambdas are great for this sort of thing to keep your code clean. Sure, the word Lambda isn't exactly the most intuitive, but once you know what it means, you know what you're looking out for. And hopefully you've learned something new in this video. If you have, then make sure to like it to let me know, and maybe consider subscribing. Distributing programs written in Python can be rather difficult. It's interpreted, meaning that it can't be compiled natively into an exe like something like C++ and Rust. And this nature, makes it difficult to, create EXEs or DMGs that people could just run natively on their computers. One solution to this is to get your user/client to install Python on their system. However, while that may work in some instances, a lot of people or a lot of, just general end users aren't going to like having to install Python just to be able to run your program. And it's a bit of a useless dependency, especially if, they're not going to develop anything in it. And then you have the whole thing about different Python versions may be causing issues, and it's just a bit of a mess. Thankfully, there is a tool called PyInstaller that is here to save the day. Now, this isn't exactly new. It's been around for a good while. I have actually used this before about 2 years ago, and it has changed quite a bit since then. It's become a lot better since then. But there were other tools as well, such as I think pipfreeze, like py2exe, csfreeze, cvfreeze. I don't remember the names for them. It's been such a long time. But those tools all had their own issues. PyInstaller was the best back then, but it wasn't perfect. They seem to have fixed a lot of the problems that it had, and they've made it a lot easier to use. So I thought, since this is still a very commonly asked question, I would make an up-to-date video explaining how it all works. To install it, you do pip install py, you actually spell install correctly for a start, that'd be useful, and then PyInstaller. And I've already got everything installed on here, so it's not going to need to do it. As I said, I'm using Windows. If you're using a different operating system, you may need to do some more setup. This page in the PyInstaller talks goes over all of that. I haven't tested any of this, so I don't know if any of it actually works. Back when I used to use PyInstaller back in the day, I was actually programming on Windows all the time. Nowadays I do it on Linux. I just did this one on Windows because it's easier for this. But yeah, you may need to install extra stuff to be able to get it to work. So I've created a little demo program to show this off. The first one is this file here, demo.gui.pyw. This pyw tells Python to launch the program without a console. If you double click it. And this just creates a simple, tkintel, tkinter, however you want to pronounce it, window with a message and an exit button, and that's basically it. It also imports this motd, which is here, and it's just, it gets a message of the day kind of thing, and there's some cool little messages there. So to actually build the program, all you need to do is open the console and do PyInstaller, and then you provide the file name. So in this case, it's demo.gui.pyw. Now, I don't need to provide this motd file because the demo.gui file imports it. So if you have this whole project built of multiple Python files, if you provide your main file, the one that actually runs everything, to PyInstaller, it will be able to work out, oh, I need this file as well, without you needing to supply it. So you don't need to supply a directory or anything, you just need to supply the root file. And if you run that, it will start building everything it needs. And once it's all done, I'll show off that it all works just fine. While that's going on, I will actually show the pyw thing for people that don't know about it. So if I double click this pyw file on Windows, you'll see the thing comes up, but there's no console window. If it was just a py file, then a console window would appear in the background. Because this is a pyw file or Python Windows file, it doesn't show it, and you're doing great. Look at that. Okay, so now that it's done, it goes in this dist file here. You can change that, I forget how to though, into demo.gui, and then you have all this stuff here And then down here you have this demo.gui.exe. You can run that and you can see it does exactly the same thing. It just shows a different message this time, but it's exactly the same thing, just now running in an exe rather than Python. So that's the basics of how this all works. There are some different options that you can employ, but before I kind of go over those, I do want to talk about this spec file that it creates. So when you run the PyInstaller command, it creates a spec file for you if one doesn't already exist. And this spec file essentially tells PyInstaller what to do. So there are a number of options here. You know, this first one is the file it needs to use. And there are a load of options here. I'm not going to go over this in detail. There's a lot to it, and the documentation kind of covers it. But I will briefly demonstrate one aspect of it, which is this datas here. So you can use this to include additional files in your distribution. And this is a list of tuples. So say if you wanted to include this README file in our distribution, because currently it's not here. There's no README file to be found at all. So if you wanted to include it, we could just provide the readme.md as the first element of the tuple, which is our input, and our second element tuple of the tuple is the output. So if you wanted it in the current directory, you'd do a dot. If you wanted it in a new folder called test, then you would put it in a folder called test. This output directory is relative, so just keep that in mind. And now we can rebuild our distribution. I've gotten rid of the build and dist folders because I don't know if that causes problems. They're still there. But instead of building from our PYW file, we now build from our spec file. If you build from PYW file, it would actually recreate the default spec and it would overwrite this and you'd lose it. So if we use this spec instead, it will be able to see that, and now it will start building exactly the same thing. But if we get our directory ready, in our dist, when it finishes up, we go in here and now we have this folder called test, and our readme is in here. And if we just open this up, we can see that it just says demo GUI and it gives us a good hello. But you may be thinking this is quite a lot of files to have. You know, there's this huge amount of things. You know, a lot of EXEs and stuff do have random files all over the place. So this isn't particularly unheard of. But there is actually a way to get rid of them all if you don't want them. And that is by doing, if I do pyinstall PYW, if I get rid of the build and dist again, I don't know if it causes problems if they're still there. We can do dash and a capital F. And what this will do is it will build it in a single file. So it will put everything in the exe. And one thing to note is that the spec file does look different if you do this. And now it isn't a collect call down here. And if you put anything in the datas, it will be bundled into the exe itself. So you can put images into the exe, for example, which is especially useful if you don't want people like modifying or stealing the images. But that also mean you can't put text files directly in it. What you can do instead, if this is done, I don't know, this is not quite done yet. But what you can do instead is, so you have your, the exe will come up here, and then you can actually just put files in this distribution, and then you can distribute the files manually as you go. So I could put, say, the README in here, and it would now be available for the program to use should it need to read it. So it's not the biggest deal in the world. If you don't want all of the crazy, DLL files and everything, there we go. It takes a little while, I think. Then you can do that, and it just bundles everything into the exe itself. I believe it is a bit slower to do, and I believe running it from an exe is slower than just running it from the Python file anyway. I don't know the mechanics of how they've gotten this to work. My guess is that it has a Python interpreter or something built into it, and it just runs it. I don't know. But either way, that is the basics of how to create an exe with PyInstaller. There's so many options that I'm not going to go over them all right now. The documentation is available if you have more advanced needs, though it does explicitly state that in the vast majority of cases you won't need to create your own spec file. So there are probably only a few options you're ever going to need to use. I've done this on far more complicated projects before. I used to, when I built a Discord bot for my friend, he used to run it on his own computer, and I actually gave him an exe file. So I compiled entire Discord bots using PyInstaller, and it worked fine. And that was using very basic options too, I believe. So yeah, that is the easy and quick way to build it. Itertools is another one of those libraries where people don't really know about it, but a lot of people would find a lot of use in it. And that's kind of what this whole, Python is Awesome series is about, trying to expose some of the cooler, less known things of Python. Itertools is actually very similar to collections, in a sense, just where collections deals with all types of collection types. Itertools specifically deals with iterators. Now, I'm not going to talk about what an iterator is in this video. I actually made a video on generators, and a generator is an iterator, essentially. But this library provides tools to work with iterators or to iterate, over collections in, different ways. So to start, we're going to import Itertools. Itertools. And I'm going to import it as IT just because I don't want to, type out Itertools a lot. And much like the collections video, I've picked out a few of the ones that I think are the most useful. I might be a bit biased in, the exact sort of things that I program, with regards to how useful I consider these things. So it might be worth looking at the entire module and see if there's anything else in there that is useful for you, because there is a lot of things in there. It's not like I think collections only has about 8, Itertools is like 15 or 16. So it'd be worth looking in there. We're going to start with the cycle. So if I were to have, say, a tuple of colors that went red, green, and blue, the itertools.cycle, if you were to pass this in, would output red, green, blue, infinitely. So if I did for I, and we're actually going to import time as well, just to make things a little easier to see what's going on. So for I in Itertools, I did the IT for that exact reason, didn't I? Colors, Itertools cycles colors. Print I and then time.sleep. I cannot, oh my words, why can I not type? Probably because the microphone's right in front of my face today. Because I did a video the other day and the microphone was over there and it didn't sound amazing, so I'm sacrificing myself for the sake of YouTube here. But as you can see, it's printing red, green, blue, red, green, blue, red, green, blue. So every time it reaches the end, it starts all over again. So it just means that you don't have to keep a track of the index and then set the index back to 0. And then go all the way through it. And it also doesn't store this infinitely long list of things in memory. One of the key things about generators is that they compute values at the time they are needed. Or generators or iterators, they're the same thing. So a cycle just yields the correct value as it needs it. One limitation with the cycle, however, is that there is no way to stop it outside of like a break. So if I were to put a break at the end, it would stop it. But outside of that, there's no way to set the number of cycles. So say you wanted to iterate over the whole thing 3 times. I couldn't just put a 3 in here and do that. I'd have to, set a variable that was a counter and then count up and all of that stuff. Or would you? Because Itertools does provide a different method to handle that. You do have to combine 2 of them. It's not as clean. But if I just comment this out for a second, what you can do is you can do for I in it.t colors, and then say we set n equals 3. You don't have to provide it as a keyword argument, but I've just done it anyway. So I don't know why it's called t, if I'm going to be completely honest with you. But what this does is it will now create 3 iterators for colors. So if I do print I, it will start printing out. Oh, it does. Okay, you can't do n equals. That's fine. It will print out, these 3 iterator objects, which is not, super useful in itself. So you could do, a for j in I or whatever, but the easy way to do it is to combine it with it.chain and then have a star here and then do that. And now if I do it, you'll see it prints. It iterates through the collection 3 times and then prints all the values in it. So this chain takes a series of iterators and it iterates over all of them as though they were 1. So say if you had 2 strings, A, B, C, and D, E, F, and you had it in there this, it would iterate through them both and then print out values as though they were one continuous iterator. So it's basically just combining iterators. And because our T function here is creating a series of iterators. If we were to then unpack them into separate arguments, we could get the chain to iterate through all the iterators and then kind of treat it as though it's n number of cycles. It's a bit of a weird one to get your head around potentially, and it's not super clean. But if you want to iterate over an iterator n number of times, and this is probably the best way to do it. The second thing I want to talk about is the islice. So if we were to have like a list, for example, 1, 2, 3, and then we would do list 1 to 2, you could do this on a list, but you couldn't do this on an iterator. If you tried to do this slicing operation on iterator, you would get, I forget exactly what it is. I think it's like generator expression is not subscriptable or something like that. But you wouldn't be able to do it. islice allows you to do that exact thing. So I've set up some test data here for kind of a more real world example than just using range like I kind of saw around. So I've got some lyrics to a pretty good song. I'm not sure anyone's heard of it as such. It's fairly obscure, but it's good. I recommend you check it out. And we're going to iterate through over, and we're just going to extract the chorus here. So we're going to extract from here to here, and this is line 6. The line number start from 1, so it'd be 6 to 11 we want. So what we can do is we can do with open. Actually, I'll show you what it would be like if you did it with a list first, just to kind of put it into a bit more context. So if you did lyrics.txt and then we read it as f, we could set it lines equals f.readLines, and then we can print lines. Was it 6 to 11? Actually, what I probably want to do is I want to put it in an iterator really. For I, and then print i.strip. There we go. That'll make things a bit easier to work out. So the read lines reads the entire file, splits by the new line character, and assigns a list of all the lines in the document to this variable that we've called lines. And then we can use list slicing like this to get the 6th through 11th lines, which happen to be the chorus, and then we can print them out. And this is all well and good if you have a file that is, how long is this? 54 lines long. But what if you had a file that was 1,000,000 lines long, or even 54 million lines long? Who knows? If you tried to read that all into memory and then try to slice it, you would probably either run into very large issues or just run out of memory completely. But what you can do instead is you can do for line in it.islice and then pass in f. So we can actually just pass in the file object. We don't even have to do something like f.read, for example. And then we can give it either a stop, so we can set, if we wanted to, just print out the first verse, we could do that. Or we could set a start and then a stop. And then we can print line.strip in the same way, and it prints the exact same thing. So what we're doing is it's iterating through this list of lines as it's processing them. So it's not storing them all at once. It's only processing them as they come. And it's essentially, keeping its own track of the index and only returning the 6th through 11th lines. This is incredibly useful, to prevent you having to convert an iterator to a list. If you have any sort of iterator and you only want to, process a range, it's almost always better to do this rather than convert it to a list in this slice. I say almost always because there are a few caveats. The first one is that you cannot have negative numbers. So if we did like lines, say -1, you couldn't have that in an iterator. An iterator wouldn't know what, islice wouldn't know what to do with that. The other thing is that it's not so easy to get a single value. You would have to, still pass like 6 and 7, for example, to get a single line. There isn't just a way you can set, a single number. The final things that I wanted to talk about in detail are the drop while and take while functions. So these act similarly to filter, but they kind of do filter until or filter from. So I'll start with the drop while first, and I have some test data here because I feel like this is probably most useful if you have like an API requests. So say, for example, if we wanted to, print everything from description onwards, so the keys and the values, everything from description onwards, but we didn't know how many keys description was. What we could do is we could do, so with open data.json r as f, and I am just going to read it. I need to import JSON. I am just going to read it all in at once this time, like that. And then we do for kv, so it's a for key value in it.drop while, and then I'm going to leave that blank for now, and then we're just going to print kv, just for experiment's sakes. But in here, it takes the same arguments as a filter would. So it takes a callable as the first argument, and it takes our data, in this case data.items, as the second argument. So if you wanted to, process every key after description, we could pass in lambda x, and an x0 does not equal description. So what we're saying here is that while the key of our API request does not equal description, ignore the data. But then once it does equal description, we want everything after that. So a filter, you would only get the description key, but with this, you also get everything after it. So you can see our profile image URL, offline image URL. We make no mention of this in the actual request itself. But because our key is now description, we've now worked out that we want to process everything after that. Or more accurately, that we want to drop everything before that. And so, now that that condition is true, it just returns everything it finds. The take while works similarly. It's just the other way around, I think. So it will process everything up to. So what we're saying here is that while the key does not equal description, then we want to use this value. The moment it does equal description, we don't want any more values. So while the drop while would take this and everything after it, the take while would take everything before it, but not including it. That's an important distinction to make. A number of other Itertools functions are slight variations on built-in equivalents. So for example, you have filter false, like this, be it.filterFalse, which acts exactly the same as a filter, except it checks if a value is false rather than if a value is true. You then have the count, it.count, where range stops. If I were to do it count 10, where range would stop at 10, count starts at 10. You then also have it.zipLongest, which works very much like zip, except instead of stopping at the shortest or at the end of the shortest collection, it stops at the end of the longest collection, and then you can supply a placeholder for values that don't exist in the shortest one. And it kind of goes on like that. And then there are a few other ones. There's like repeat and all this stuff. I might as well just show you slightly. So stuff like pairwise, star map. You then all have these combinatoric, which I love as a word. Ones, so you can kind of look at all the permutations of an iterator, for example. There's a lot of things here. I just kind of shown off the more useful ones because I didn't want this video to be 25,000 hours long. As I say, you can have a look through it in your own time and work out if anything is useful for you. If you found this video helpful at any point, then consider liking it to let me know. I'm kind of amazed I haven't made a video about Pathlib yet. It's one of my favorite standard libs within Python, and it's so good and so easy to use for file management. It's actually kind of unreal. I use it all the time. And I'm amazed, when I came up with the kind of original sort of ideas, things to do for the Python is Awesome series, that Pathlib wasn't one of them. I suppose in part because Pathlib is one of the more well-used ones. It's not so much overlooked as, a lot of the other ones in this series. But I thought, seeing as I love this so much, and I've used it so much, I thought I'd make a video about it because, there'll be some people that don't know that are still using os.path when Pathlib is kind of the better way really to be doing things. So I thought I'd make a video on it for you. So we're going to start by importing Pathlib. And I'm going to show you, various things. As always, I've picked out a number of things to show you. There's nothing really that complicated here, and so I'm going to be showing you kind of a lot of things that Pathlib can do. These are some of the more important things, some of the things you might be doing in the real world, like reading files and stuff like that. But we're going to start by creating our Pathlib objects, because there are a few things to talk about even with that. So we're going to do path equals pathlib.path. I hit shift at the wrong time. And then we're going to print path. And what that will do is it will just print a dot, because this creates a path for our current directory. So a dot, for those of you that don't know, represents the current directory. So when you have a pathlib.path, it creates a relative path for the current directory. If you don't want a relative path, you can instead use the .cwd class method, and that will actually now create an absolute path for you off the bat. You can interchange between the two, but these are two different ways to create it. So if you don't want to create a path and then absolute it, you can just use the CWD. Again, that creates the exact same directory. If you do a truthy check on the two, it will actually return false because one is relative and one isn't. So that's something to keep in mind. Of course, if you want to create a path for a specific directory, you can. So you can either do a relative directory by like starting it with // or something, or you can do an absolute directory by doing /. Well, in this case, etc password is the example that I've gone with. And you can see it creates a path at etc /password. And this, I believe, is absolute. This is kind of one of the things you can check. I might as well show. Here you go. So that one is absolute. If I were to do, say, etc.password without the /, it wouldn't be absolute because it treats it relative by default. So again, something to keep in mind there. Once you actually have your path, I'm going to kind of reset this to the current working directory, and then I'm going to have it as this file, pathlib tut.py, short for pathlib tutorial. If we print that, we can see that is, our pathlib tutorial.py. This path is formed of various parts. So you have, if I were to print your path.name, and if I just copy paste this, you have your stem, you have your suffix as well. So if I get rid of this first one, actually, because that's just confusing things. So you have the name, which is the actual name of the file. You have the stem, which is the actual kind of file name without the extension, and then the suffix is the extension. So the name is formed of the stem followed by the suffix, basically. You can also print path.parts, and I'm going to copy paste this again, resolve, and then as URI. And these are just different ways to represent, a relative, that actually needs to be absolute. I did not know that. So the path.parts kind of prints out all the different parts of our file. So in this case, because it's a relative directory, all it really knows is the file name. But if we were to do, say, path.resolve, which turns it into an absolute, then you have all your different parts here. So you have your / and you have home, Parafox here, programs. This is all the different files that it takes to get to the actual file itself. The resolve works similarly to the absolute. I'm actually not 100% sure what the difference is, even though I've used a different one here and here. But the resolve essentially calculates the full file path to the file. So you can see we start from /home and it does that. And then you have your as URI, which, as I've just found out, needs to be done on an absolute file path. Essentially prints out in something that like Firefox would understand. So if I were to open this in Firefox, it theoretically, if Firefox were to ever comply with that request, which I don't think is going to do, then it would be able to print it out like that. So those are different parts of the path you can access. Those are different ways the path can be represented. Now I'm going to show you, I'm just going to comment these all out again. Now I'm going to show you different ways in which paths can be manipulated and kind of, operations can be applied on them. So the first thing I want to show you is kind of different existence checks. So you can do a path.exists, and we'll do a print again. Just to test whether or not something exists at that file path. So this could be a file or a directory. If you just wanted to check for a file, then you could do is file. And if you just wanted to check for a directory, you could do is dir. So here we get true, true, false, because this file that we're manipulating right now does exist. This exists false, true, because it is a file. This false, true, but this one false, false, because it's not a file, because it's a directory. If I were to do this, then we get true, false, true, because this is now a directory. This is just our relative directory. If I were to give it a file that doesn't exist, then it would be false, 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 because the file doesn't exist at all. And it's not a directory either, and even if it was, that wouldn't exist. These kind of fall in line with os.path.exists, os.path.isFile without an underscore, and isdir without an underscore. I believe they do the same thing, but you just don't need to pass the actual string path in there because you have an object saved for them. If I just comment these out again, I'm kind of just leaving all these things in here. And if I just set this back to our normal one, like that, I'm going to show you how to read text and bytes and stuff from them. So Pathlib does include functionality to be able to do that. So you can do, say, text equals path.readText, or if you wanted to, you could do read bytes. I'm not having the variable name as bytes because that is an actual type you can do. And then if I print text, I will just do one at a time, otherwise it's going to get really angry at me. I don't know why that's freaking out. Or maybe because it's the current file. So if we do, I don't really want to do this. This is kind of a plan I've got going for a future video that's not finished yet. If I do, say, rickroll.txt, just completely at random, and do something like this. Something just selected completely at random. I don't really know why I've done this. It's quite an obscure song, if you've never heard of it. You might, it's worth looking it up, I would say. But if we were to then load that, I did actually work out it didn't work because this file is open in the editor, which I should really have been able to work out myself, but never mind. You can see that we're now reading the text, and this includes the extra new line that Visual Studio Code is putting at the end. So you have, never gonna give you up, never gonna let you down, etc., etc. If we were to then read this as bytes, we can then print that out, and it would return a byte string instead. So you have the option to read as text or bytes. I believe if you have an image, in that case, or like a sound file, then you can use read bytes, and it will work perfectly fine. Obviously, text is only for text files. That's probably very obvious, actually, but there you go. And now we've done that. So if I just again comment this out. And move it down. I'm going to show you how to start creating things. So you can create a new file. So if we had, just have rickroll.py. You can create a new file just as is by using path.touch. So this works similar to the touch Linux command. I don't know if a similar command exists on Windows at all. That does bring into question whether this would work on Windows. I'm pretty sure it would. I can't see a reason why it wouldn't. But I've worked with things with different operating systems, and I've had to be compatible, and it can be a real nightmare making it compatible for both Linux and Windows. But we're not talking about that right now. But this will just create a file called rickroll.py, and if we wanted to create, actually we'll do it one at a time. So now we have our rickroll.py file that is created. It is empty because we haven't written anything to it. We can also, if I get rid of that, have path.makedir, and if the directory doesn't exist, then it'll make it. I believe if it does exist, it will error. Yes, but I believe you can also do exist OK equals true. So this works very similarly to os.path.makedir, I believe. I think the files are largely the same. I don't actually know if os.path has a touch. That would be interesting to find out. I'll put it on the screen. I'll look it up and put it on the screen whether it does have one. I've just never used that before, really, so I wouldn't know. But yeah, if you've used os.path before, you are probably seeing a lot of similarities between Pathlib and os.path. The main difference is that you have your object that you then run your operations on, rather than having to call an external function and then pass something into it. Interestingly as well, os.path functions can accept Pathlib objects, which is kind of funny. So now I've shown you how to create new files and directories. I'm going to show you how to write to them. Now, one difference between like writing stuff using Pathlib and writing stuff, say, using with open, is that the file does actually need to exist before you write to it in Pathlib, but there's no options to create the file if it doesn't exist. So that's probably where path.touch comes into it. There is a way that you can use Pathlib with context managers like that, but I'll get into that in a bit. So if we just get rid of that again, we come down here. Actually, if we move this up, it'd be easier than just kind of writing all this new data back out. So if we set this to rickroll.py, so the file does exist still, we can, using this path, do path.write bytes. We'll start with the write text, and we'll do text. So you can put the encoding in there and everything as well. I'm not going to bother doing that here. If you run that, then our rickroll.py doesn't have anything in it. Why does it not have anything in it? Right, I realized then that I was reading from an empty file and trying to write everything back into it. It's the joys of doing things in a tutorial, ladies and gentlemen. But now we have our actual text, and we can write our text in there. We can see that, well, okay, we've written text document, we've written text content into a Python file, but you can see that the text is now written in there. If we were to convert this to a bytes thing, and if we did, actually, we'll just leave that as text. I can't be able to change that. But if we do write bytes, so this is now a byte string, and that goes in there, and it does exactly the same thing. So it's just writing it in. So it really depends on, I suppose, the format your data happens to be in at the time, which one you use. Again, just keep in mind that if you're writing image or sound data or something like that, you need to use bytes. Probably fairly obvious, but just in case. As I said before, you can use Pathlib in file managers, not file managers, context managers. So you could do with path.open, and you set your mode in here. So we're going to set it in write mode as f, and you can do f.write text, and it will do exactly the same thing. So we now have our text in here. If I get rid of that, and then if I run it again, we can see the text being written in real time there. So it does exactly the same thing as with open would normally do, except you just again have the path stored and you're not passing it into the first argument. That really is kind of Pathlib's main thing, I suppose, that you just store paths. But it is very useful for this sort of thing, I think you'll agree. Final thing I'm going to do in this video, I know it's quite long, it's longer than I thought it was going to be, but there is a lot of useful stuff in it, is to be able to recursively search through directories. So if we do, say, p in path.glob, because this returns an iterator, not a list, and if we just search for all our py files, and then we print p, then we don't find anything. Oh yeah, because this needs to be a directory, doesn't it? I forgot to change it. So if we just search for our current directory, these are all our py files. So we see that this txt file isn't in there. I'm not going to explain glob syntax in this video. If you want to see me do a video on glob, and maybe I might do something on regex as well, and do leave a comment down below. But yeah, this is just kind of showing you how to use it with the assumption you already kind of know what glob syntax is. You can also do recursive glob using rglob, and it starts searching through the venv and that. This is functionally equivalent to this, and yeah, that does exactly the same thing. So you don't actually ever need to use rglob if you don't want to, but you can do if again you want to. So yeah, that covers everything that I wanted to talk about. It's a bit of a long one, I know, but there's a lot of really useful stuff in Pathlib. And hopefully when you make your next project that relies heavily on opening and closing files and writing things and all sorts of stuff, that you'll use Pathlib and you'll find great use and ease of use in it. If you like the video, then consider liking it to let me know, and maybe... The tomllib module is the first module to be released in Python, or the first new module, I should say, to be released in Python since version 3.9. So I thought I'd do a nice little video about it, talking about, really briefly. It's a really simple little module, so we're not going to be here for very long, but I thought I'd cover it in more detail. If you haven't seen my Python 3.11 guide video that I did on Monday, I'd recommend going and looking at that. We're going to be covering the things mentioned in that video in more detail over the next few. So next Monday, or next Friday, next Monday, we will be talking about exception groups, And then next Friday, we'll be talking about async task groups. If there's any other features that people particularly want me to talk about, do let me know and I will talk about them. I'm probably not going to go over the self-type because that seems self-explanatory. But again, if you want to see that, do let me know. But today I thought I'd do, the new module first, because obviously new is exciting. And this is really useful for people that need to be able to load configuration files, especially for libraries or something that need to be able to load like a custom configuration file. So if you've built anything for the Python package index, you've probably heard of or seen or even used a pyproject.toml file. This file generally includes all your configurations for your tools. So we have our build system here. We also have, config for the black formatter, the isort import sorter, MyPy type checker, etc., etc. And before Python 3.11, there wasn't actually a native way to load a toml file into Python. You had to, download something like toml or tomly. I think there's quite a few of them out there. But now you can load them in using the built-in module. One important thing to note is that you can't write them. That was not implemented because apparently, I don't know really anything about it, so I couldn't comment on it personally. But in the stream that the Python Discord did, they mentioned that writing toml files is actually really difficult. And there's a feature called, I think, ring-roading or something that people would want if they implemented that, and apparently that's even worse. I suppose they wanted to spend their time on other things, so maybe they just didn't see the need to be able to write toml files when really you're just using it to load a config, because you're just going to be typing it in the actual main editor itself. But actually loading them is very simple. It's very similar to the JSON library, actually. So we can do import tomllib, like so. And then we can do our with open pyproject.toml. And while it is similar to the JSON lib, there is one caveat, and it's here. We need to specify the mode as read bytes. If you don't specify it as a bytes, it will error, telling you that you need to open it in a binary mode, which is interesting. I don't necessarily know why that is. Again, I'm not used to parsing toml files, so if anyone does know, do let me know, because I'd be interested to see why that is the case. But we can just open that as F, and then we could do, say, config equals tomllib.load F. And then once we print config, we can see our config file here. So what it does is if we look at tool.black, for example, we have our tool here as a separate thing, and then it has a dictionary which contains all of the subcategories. I'm not really sure what you call it in toml, but you have your one for black, and you have your one for isort, and you have your one for MyPy, etc., etc. So that's actually really nice. I quite like that. I guess that's how you would do it, but I've never really used one of these before, as I say. So if you wanted to, say, get the line length for black, you would print config, and then you print toml. Actually, if I move this to the side, it might be easier to see what I'm doing. So we have our, not toml, tool. So we go into tool, and then within tool, we go into black. So we've now moved from like this section to just here. And then we want the line length specifically. So we pass line length like that. And then once we load it up, we can see that we get a line length of 88. So that is how you can, load toml files, and how you can, access specific attributes within them. I will quickly show off how to use the loads function, because it is actually a little bit different. So if we just comment this out for now, if we do with open, actually, if we just copy paste this for the time being, that's not what I wanted to do. I'm hitting all the wrong buttons here. There we go. Config equals tomllib.loads f.read. Now the weird thing about this is that you don't actually have to open it as a binary file when you use load. So if you get rid of this, it now loads fine. I don't know why you have to load it as a binary file here, and I'll prove that you have to load it as a binary file here, but you don't have to load it as a binary file when you're using loads. Like, to me, that seems a bit weird. See, there we go. That's the error you get if you don't load it as a binary file. So for some reason, if you use the load, it needs to be loaded with the read bytes mode. If you use loads, it needs to be loaded as a string. If you load it as a bytes, you'll actually get an error as well. I don't quite know why that is. It's really weird, but that's a thing. So that might, influence how you use it. It might not, it probably won't, to be completely honest with you. So that's everything that I wanted to talk about in this video. If you like, alongside the speed improvements, Python 3.11 added a lot of new features. I've already talked about the tomllib module, the brand new module that was introduced in last Friday's video. And I'm going to be talking about Async TaskGroups in this Friday's video. However, in this video, I'm specifically going to be talking about exception groups and the except star syntax. These features lie within Python 3.11's more broad exception handling improvements, which include better messages to better show kind of where exactly an error is being raised, or what exactly is causing the error, and notes that you can add to exceptions as well to provide more helpful exception tracebacks. Exception groups and the exception star syntax specifically provide the ability to raise and handle multiple exceptions at the same time, which is really useful. For example, if you have multiple async tasks running at once and they all throw errors, or at least some of them throw errors at the same time, you want to be able to debug them all at once rather than handle one and then you run it again and you run to the next and you run to the next, and it just takes forever. I did say in my Python 3.11 overview video that I did on the day of release that I wasn't particularly a fan of the exception group syntax. However, having used it a little bit, I'm actually not too fussed by it. It looks a lot worse when you have nested exception groups, but in its raw form when you don't have that, and to be honest, you're probably not going to have nested exception groups that much anyway, it's not actually that bad to use. So to create them, I'm going to create a variable just called exception group, and we're going to use the exception group base class, and then we're going to pass our message like we would for a normal exception. This is an exception group, but then we also need to pass a list, or it can be a tuple, of exceptions to be handled within this exception group. So I'm going to pass an error, a value error, sorry. Value must be greater than 0. And I'm also going to use a not a directory error as well. Must be a directory. This is probably kind of a lesser known built-in error, but it does exist. So if we don't need to do a try there. If we do raise exception group, my choice of variable name is causing some issues for the autocompleter. Once we run that code, we have this error traceback here. So it looks fairly similar to a normal traceback, but there are a few changes. First, this kind of whole structure with the pluses and the hyphens and everything. So you have your exception group traceback, most recent call last. You then have some information about where it was raised, and you have the main exception, the exception message, and number of sub-exceptions. And then both of these sub-exceptions are listed under 1 and 2. You have our value error and our not a directory error in here. And while these can be handled using a standard try except and catching an exception group and iterating through exception group.exceptions, this isn't the way it's designed to be used, because the exception star is designed to be used for this. So if we do try except, and then we can do except star, value error as EG, and then I'm going to print handling value error. I don't exactly know why I've done it as an F string. I kind of have a bit of a habit, because most of the time when I print a string it is a formatted one. So I skip forward a little bit to after I finished typing everything out, because I thought we don't necessarily want to watch that. But this except star syntax here is actually filtering out types of exceptions from the group. So if a value error is found within the exception group, which in this case it is, that value error is filtered out, or it's actually removed completely from the exception group, and it's returned as this exception group here that we can do things with if we want to, and then it will move on. So long as there's another error in the chain, it will actually move on to our not a directory error, see if it's there, which it is, and it will handle that as well. And it will remove that from the group. And because we're handling all of our exceptions, we get these print statements. And because there are no exceptions left within the exception group, by the time we reach the end of the try except block, we don't actually receive an error. If I was to add a third error, say a type error, and say must be an int, and we run it again, not a dot, that used to be a comma, there we go, we will actually get our error here, but we only get the one that we haven't handled. So the value error and the not a directory error have been removed completely, and we're just left with the type error that needs to be handled. We can also add multiple errors of the same type. So if I add another not a directory error and say still must be a directory. If we run that, we won't get errors because this takes all instances of an exception out of the exception group. So in our EG, we have, if I just do print eg.exceptions, we'll see we have a tuple of our two not a directory errors. So these need to be handled separately to each other. And you can use a for loop to iterate over the exception classes and handle them all individually. But if you do have multiple of the same type, then you do need to actually do a little bit more work in order to deal with them. However, I can't imagine that would be a thing you need to worry about in the vast majority of use cases. Now, there are some things to keep in mind. As I said at the start of the video, exception groups can be nested within each other. So an exception group is a subclass of exception, meaning it can be passed in. If you have that, let me just implement that real quick. So if we have this, where we have our value error, and then we have an exception group containing our not a directory errors, and then we just raise the exception group as normal, then we will get this very funky looking error trace back. This is what a lot of the examples used. They had a lot of nested stuff, and this is what I don't really like because this is just really confusing now to me. So you have your exception group, and then you have a second exception group, and then within that you have your 1 and 2. I feel like these should maybe be like 2.1 and 2.2 just to make it a bit clearer, but I don't know, maybe that's a bit much to ask for. I don't know how difficult that would be to implement really. But that is one thing to keep in mind, that exception groups can be nested. Another thing to keep in mind is that you cannot have except and except star statements in the same thing. So if we were to do type error as exception and then just do that because it's going to give us an error, it will give us a syntax error saying cannot have both except and except star on the same try. So you do need to keep that in mind. However, it's not the end of the world because except stars can be used to handle standard errors as well. So if we were just to raise a type error saying must be an int, and then we use our except star down here, and then we do handling type, I can't be asked to use the shift key, then it will handle it as normal. So except star can be used in place of except, but except cannot be used in place of except star. In that sense, except star is an extension on except rather than a brand new thing in its entirety. So that's everything I wanted to talk about when it comes to exception groups. The last few videos on my channel have been talking about various new features in Python 3.11, from a general overview to the tomllib module to exception groups. If you want to have a look at any of those, they're in the cards. In this video, we'll be talking about async TaskGroups. This is the last video I have planned on kind of a more detailed explanation of new things in Python 3.11. If there is anything else you want to see me talk about, do let me know in the comments and I will go over it. This wasn't touted as one of the bigger improvements. This was actually kind of put in under the improved modules rather than the release highlights. However, as someone that uses async a lot, this is actually a really cool thing and fixes a problem literally that I came across last night while I was trying to program something. The task groups would have been really useful if I didn't need compatibility with older Python versions. So I'm going to talk about that here. I've got some code already on the screen, so I've got a simple count task that we're going to use as an example to show off these task groups. And I'm also going to create a main async function here, and then I'm just going to do async io.run main in the bottom here so we can run that. So a task group is more or less what it sounds like, to be completely honest with you. It is a context manager that you can add tasks to, so you can append your task to this task group, and it will wait until all of these tasks are done before moving on to the next bit of code. If an error or multiple errors are encountered within the task group, it will actually raise an exception group, which is kind of funny actually. It's almost the first thing to kind of use exception groups in itself. If you're unfamiliar with exception groups, I did do the video on that, as I said in the start, but I'm going to start creating this task group now. So you can do an async with, so this is an asynchronous context manager specifically, async io.taskgroup, and we're going to call that as TG. And then to create a task within this, we just do tg.createTask, and then I'm going to put the count in there, and we're going to say 5. And then we're also going to say, have another one that says 10. I'm fully aware I can use a for loop but I feel like it might be a bit clearer to have it like this. So don't shout at me for not using a for loop. So if we run that, this is all the stuff. I've just come off the back of recording the exception one, actually. If we run that now, then we can see that our tasks run perfectly fine. And actually, that's something I forgot to do. I was going to put like all done here to show that the all done only gets printed once all of these tasks are complete. So we can see they're running asynchronously. You have your 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then it goes 6, 7, 8, 9, 10, as this second task takes a little bit longer than the first. And we have our all done in here. This replaces async.gather. If you needed the results of them, because async.gather had obviously, it returned the results of each task as a list, you would actually need to, say do T1 equals that, T2 equals that, and then once they're done, print, well, this is going to be none in both instances, but you would do something like this. So you print T1.result and print T2.result, and then you'll get your none and then none again, because it doesn't return anything. Actually, if I make it return n, that might be a little bit clearer. So we now have a 5 and 10 in there as well, and that is how you would do it. So you don't actually have any sort of task group.results or anything. I think that would be quite nice to have, actually, but I just looked through the autocomplete and it wasn't there. So maybe something in 3.12 to be added. Python have made it clear that task groups are now the kind of officially accepted way to do things. Or for new code, it said to use task groups over async.gather. Of course, if you need compatibility with older versions of Python, if you're doing like a Python package index library or something, then you would still use gather rather than the task groups. But if it only needs to support 3.11, then you can use task groups and should use task groups instead, according to Python. Now, before I go, I do want to briefly talk about this exception handling thing that it has. So if I just get rid of this, because we don't need it, and then we copy paste this, and we start giving it some invalid tasks. So say we want it to count to a string of 4 or to a value of 1.5. Both of these should fail, and both of them do. And we get this exception group here. We get quite a big exception. So we have this huge information about how the exception group was raised, but then we also get the 2 sub-exceptions. So we have our first one. This is caused by our task here. So it's can only concatenate string, not int to string. And then we have our second one here, float object cannot be interpreted as an integer, and we get them both at once. So in previous versions of Python, if we were to do something similar with async.gather, for example, then we would only get this first exception, and we wouldn't get an exception for the second one until we fix this one and ran it again. But now that we get both exceptions at once, we can actually fix both of them, and we'll get perfectly functioning code a little bit quicker. You can also see the improved error message in action here. So the arrow is pointing to the plus, and you have your arrows pointing just to the statement here, which is kind of a bit weird. You'd think it would just point to the n again, but I don't know. I guess some things they didn't do that for. But I mean, either way, you can pretty easily work out what it's referencing, so I suppose it doesn't matter too much in that case. But yeah, that's all I wanted to say about task groups. They are ultimately very simple, very cool, really useful little utility, but ultimately very simple to use. I guess that is the good thing about them. But yeah, if you do like the video, then make sure to leave a like and let me know. I know it's been a little while since I recorded a video. Sorry about that. I do have my reasons. However, I'll talk about those in either a separate video or in a community post or something. I don't want to saturate this video. But I am back now, and I'm going to be doing probably a video a week going forwards. Again, I'll have more details about that in the little update I'll do. But today, we are looking into Python's magic methods. So these are kind of special little methods. They can actually be called special methods. They can also be called dunder methods, and these have various purposes within a class. So they can be, a constructor. They can control how the class is represented. They can control operator overloads, for example. So yeah, these things are very useful, and there are a lot of them. In this video, I'm not going to go over all of them. I'm going to go over a decent chunk of them. It helps that a lot of them are quite closely related. So I can actually go over quite a lot of them without having to talk about a great deal of them. So this video won't be too long. But there are plenty more for you to kind of scavenge around if you want to find out. But these are, especially if you're new to object-oriented programming, or if you're just looking to get, a little bit better with classes and looking to, answer some questions about how to represent certain things or how to do certain operations, then I'm here to show you that. And I'm just going to add one to my notes because I just remembered there's one that I particularly want to talk about. So we'll start by creating a class, and we're going to do kind of my, my go-to. And we're going to create a human class, and this class is going to have the name, the age, and the jobs. And we're going to set that as none by default of the person. And then we're going to have self.name equals name. That would help if I actually did that properly. Self.age equals age. Self.jobs equals jobs. Nice simple thing. This one uses the init special or magic method, whatever you want to call it. And this is probably the one that you would have seen the most. Because if you've created any class in Python, then you probably would have used this. This is the main constructor. This initializes the class, hence why it's called init. And you don't have to provide it, though generally speaking, at about 90% of instances, you probably will want to do something with it. Unless you're using like data classes or attrs or something, then you don't have to worry about it. But I'm not going to spend too long talking about that. But I do want to talk about one called def init subclass. I'm not going to go into huge details about this. But I did want to bring it up. We can get rid of the type hints. We don't need to complicate matters. And if we just say, meme equals none here, and I'll show you how this works. So if we just set a class attribute here, and then to say we had a subclass called like test or something, and it inherited from human. And we don't have to do any of that, but when we initialize a subclass, this actually gets called, and this kind of takes over the role of meta classes in some respect. I'm not going to talk about meta classes today, but this class is the test class, and then the meme here, what we can actually do is we can pass it in here. So say if we do like rickroll, for example. I'm not going to bother with this class attributes actually. I feel as though it's just going to complicate things, but we can print meme. And then if we run that, whoops, I've got one called magic plan, which is why that worked. We get rickroll. So essentially what's going on is we're creating this, we're inheriting from human. This init subclass is being run. It's taking this, which is an instance, not an instance, it's the class of test. And then anything we pass in here as arguments or keyword arguments, then get passed as init subclass. So this is useful if you want to like register subclasses within the class, or to be honest, that's the only use case I can think of. I did look this up. I haven't really found a use for this ever. But there may be some people that do have a use for this sort of thing, so I thought I'd bring it up while I was talking about the magic methods. I'm not going to talk about it in any more detail than that. This might be a separate video on its own, but I thought I'd mention it considering I thought it was cool. So we're going to move on to kind of representing classes in different ways. So, how to represent it as a string is a particularly common one. You can use this def string, and then we can say return self.name. So now if we were to, print our human object, say if we, create one for me, my name's Ethan, I'm 24 years old. Then when we print the actual class itself, then we print what's in self.name. If we didn't do that, then we'd end up with this here. So this provides a human readable way of using it in a string. If you want a more detailed version of that, you can also do repr. And this is like the string representation of the class. So in here, you'd potentially want to do something like human. This is kind of the data class format. So you could do self.name and then age, because self.age, I'm not going to bother putting jobs in there. But now, if you print that, it still does the string representation by default. If string isn't defined, it will do the repr by default. You can also use repr here, and then it would print the string or the detailed string representation, I guess you call it. And this is really useful for like debugging and stuff like that. You know, it allows you to see, you know, kind of that you're manipulating the right thing. And one particularly common trait with these dunder methods is that they tend to define what happens when the object is called in certain circumstances. So, for example, the repr function, the dunder repr is called. If you were to do like an int, for example, then you would use def dunder int, not to be confused with dunder init. They are, you know, very similar. In this case, we can do self.age, and now it will print 24 to the console. You can also have float, which returns a float number, and you can also have hash. I'll just do hash real quick, where you essentially just do like your own custom hash. I don't remember. I think if you don't define this, it will just do it. Maybe? Let's find out. Let's find out live. I didn't test this before. There we go. It automatically does one for you. So you don't need to define it, but you can define your own one if you want. So, you know, if you want, say, 2 classes with the same name to have the same hash, then you can do that. Or you can provide a hash that was a tuple of all of them. I think that might be what it does by default. But it's worth noting nonetheless. So with representations out of the way, that's probably not all of them. You know, there's complex and stuff as well, but, you know, I'm just skimming over the ones that are potentially more useful. You know, you can always look up if you have any more queries. But I'm going to move on to operator overloads now. So I'm only really going to talk about one of these in detail because a lot of them work kind of the same. So I'll leave all the rest there. So if you want to override what happens when you add 2 classes together, for example, you can use the dunder add. So this would be, you know, say if you wanted to do, well, say you had me, which is a human, the name Ethan, and I'm 24, and then you had Barney the dinosaur. I don't actually know how long Barney the dinosaur has been on TV, but let's say 50 years. I don't know if that's right. That's probably a bit much. And then we wanted to do, you know, add the 2 together. Like this. So we want to like control what happens when we use the plus operator. What we can do is we can have this self, and this other is kind of the other class. So the self is this end or this side, and the other is the right hand side. So Ethan would be self and Barney would be other in this instance. And then we can, you know, do something like return self.age plus other.age. And if we did that, then we get 74 because 24 plus 50 is 74. One thing to keep in mind is that you might not want to, you know, do this if the 2 objects are of different types. So say, for example, you know, Ethan was a human, and then Barney, you know, we created another dinosaur class, and then maybe didn't have age, and then it would error, and we didn't, you know, want to deal with that. What we can do is we can actually do the check, and if you work with MyPy, it will actually tell you to do this. You could do if not is instance other, and then we can do self.class. Whoops, I don't know how that happened. What we could do is we can return not implemented. And it's important that we don't raise not implemented error here, because some of these dunder methods, and this is only a thing you do in dunder methods, some of these dunder methods kind of have alternative implementations that they then do if not implemented is returned. Others, I think this one, it would just raise an error immediately. But in dunder methods, it's recommended that you do this. But essentially what this does, if the right-hand side operation is not the class you expect it to be, then you can return this, and then Python will handle it from there. So I think maybe in one of the list-based ones, or like the sort, perhaps it does something with it. I'm not really sure. I haven't looked too much into that. So on top of add, you also have sub for subtraction, mul for multiplication, floor div and true div. So floor div is if you were to do, say, with a double slash, and true div is a single slash. You then have mod, which is the modulo operator like that. And then you have pal, which is the double asterisk operator like that. And you can override all of these. I'm not going to go over every single one because the things would be largely the same. You know, the only thing that would change in the subtraction one is I'd do that. You know, so yeah, these would be something that you implement on your own. So on top of all these operators, you also have additional operators that can be used with plus equals. So say, for example, we want to do Ethan plus equals Barney and then print Ethan. The add dunder method wouldn't be sufficient for that. We would need to do the def I add, and then that takes self and other. And this is largely the same. You know, you'd have these same things. Instead of doing this, you would do self.age plus equals other.age, and then you would actually return self. So it's a little different. But now, if you run that, then we actually print the correct thing, or at least something that's useful. We can see that, you know, the age of me, I've suddenly gotten 50 years older while recording this video. So yeah, this, you know, you have your iadd, isub, imol, ifloordiv, iTrueDiv, imod, ipower. You have them for all of them. And, you know, as I say, the operation is going to be largely the same. You just need to make sure that you return self, because, you know, obviously what you return out of here is what's going to be set, is what Ethan is going to be set to. So do keep that in mind. Next, I'm going to talk about comparison operators. So, you know, if you do something like this or something like this, we can also put that back in a print statement now. So with an equals, for example, you would want to do def eq self.other, and you would have this same thing, this check here. But one thing you could do instead, if you wanted to, is just return false. Because if the two instances aren't of the same class, then of course they're not going to be equal. So you don't really need to return not implemented. I believe you can, and it would return false anyway, but don't quote me on that. I tend to just return false directly out of this. And then, you know, in our case, we could do, you know, self.name equals other.name. If you wanted to, you know, include the age as well. So if you wanted to make sure that the class, the equal people had the same name and the same age, that you could do that. Or if you could do the jobs if you want. In this case, you know, if you have two people have the same name, then they're the same person, because that's how it works in the real world, I think, as we all know. You do also have def any as well, which is, you know, your not equals, so that kind of works the same. You can basically just program that as return not self.eq if you want, like that, and that'll work just fine. You also have LE as well, which is less than or equal to, LT, which is just less than, GE, which is greater than or equal to, and GT, which is greater than. If I just kind of show one of them off, so say LT, again, don't want to be here for absolutely ever. We could do self.age is less than other.age. So in our case, less than, it'd be the left-hand operation is less than the right-hand operation. So do keep that in mind. So if we just print that, we can see that, you know, I am younger than Barney, therefore, you know, the LT is true. If I do this, our names are not the same, so the check comes out as false. If you weren't to do any of these operations, so if you weren't to do any of these comparison operators, or if you weren't to do any of the operator overloads, a lot of these things don't have inbuilt ones. So the string and the repr do have inbuilt ones, for example, but, you know, operator overloads and EQs and stuff don't, unless you're like inheriting from another class or something. To say if you're, you know, inheriting from the int base class, then it would have, you know, add, iadd, EQ probably it would have as well, all this stuff. But on their own, like a class on their own doesn't have all of this. So if you do need it and you do need to add it yourself, of course you don't need to add all of them. But that's just something to keep in mind for those. So while we're on the topic of operators, I want to talk to you about something I actually learned the other day, which kind of gave me the inspiration to do this video in the first place. And that was def contains. So we could do self and then key. Well, I suppose it'd be value, maybe would be a bit better. So this is if we were to say, you know, if to do, you know, Ethan in like a list of some description, it would then call this. Sorry, this is actually wrong. It would be if, say, you know, programmer in Ethan, for example. So if my jobs, if I set my jobs real quick to programmer, then if I did, you know, return value in self.jobs, then if, you know, programmer is in ethan.jobs, which it is, it will return, once I get it right, true. See, that's something I learned really recently when I was doing some like a class that handled version constraints, and that's a really nice little shortcut for something like that. You know, if it's like a dictionary subclass or a list subclass or anything like that. Now, this video is getting a little bit long, but there is one more thing that I want to talk about, and that is the def get item, and to a slightly lesser extent get atra, but we'll talk about that. So this is actually kind of works sort of the same way. So if I were to do this in this example, looking at the jobs and then key, what I could do is I could do, say, print Ethan and then, you know, slice it like a list, and then it would be P. Interesting. Oh yeah, because this is actually supposed to be a list, isn't it? That was kind of how that was designed to be. There we go. So now I don't have to, you know, supply Ethan.jobs. What this is doing is it's calling get item. The 0 is going in here. So this works on lists and dicts. So if jobs was a dictionary, for example, I could do, you know, programmer here, and, you know, programmer could have a value. As soon as we're doing a list, it would be a number. And then it would go in here. It would then, you know, index the self.jobs, and then it returns that out. This is how NumPy does its fancy syntax with its commas and with its, well, yeah, it does have commas in it actually, and its colons and all that. I was going for columns and rows, but it means the same thing, I suppose. So yeah, there's also, you know, getatra, which is only really useful if you have like a config thing or like a dictionary. So one example of this is kind of something I did in the real world. Let me zoom this in a bit. It's like a configuration class which kind of just holds configurations. So it loads a config file, and then does all this stuff, and then you have this, you know, getatra, which resolves a key from the environment variables, and you have getItem, which does the same thing. So this allows you to say, you know, Ethan.programmer, for example, if programmer wasn't something that was set up here, you know, maybe you could look it up in a dictionary or something like that. So yeah, that's basically all the ones that I wanted to talk about. There are so many others out there, and a lot of them are quite useful, but this video is already getting pretty long. It's longer than I thought it was going to be. I'm glad I kind of limited it to what I did. But yeah, if you found it helpful at any point, then do consider leaving.